Hello, good morning.
Morning. So good morning, and welcome back from the break. Welcome to the research track. Just a reminder, we are going to have 20 minutes for the presentations and 5 minutes for the questions, as before. We have two papers, very interesting papers. The first one is the title is Automatic Translation for Multiple NLP Tasks, Multitask Approach to Machine-Oriented NMT Adaptation. And this paper is by Amir-Hossein Tebifakar, Matteo Negri, and Marco Turchi. And I guess Amir-Hossein is going to present. So I leave the floor to him.
Okay, thank you. Hi, everyone. I'm Amir-Hossein Tebifakar. Today, I'm going to talk about automatic translation for multiple NLP tasks. So I would like to start my presentation with an example to see what do we mean by machine-oriented translation. Consider that we have a text in Italian and we want to use a sentiment analysis classifier in English to classify this text. The simple approach is to use an NMT model to translate this text into English, and then using the sentiment classifier to classify the translated text. But what we want to do is to adapt this NMT model in a way that we can translate to something easier for the classifier to do the classification and getting the better performance on the English side. So it was the work that we did before, and in this work we are trying to do this adaptation for multiple downstream tasks. So I want to start the presentation with an overview on neural machine translation, and then I define the machine translation for machines. So as you know, an NMT model is a probability model that can get a sentence from one language, and it tries to do the inference and do the translation on the other language. And these models are usually parameterized with the sequence-to-sequence neural networks, which consist of one encoder to encode the source sentence. And on the target side, the decoder tries to do the translation to the other language. These models are usually trained using parallel data. So we have a loss function, which is the maximum likelihood estimation. And during the training, we try to maximize the translation for each sentences in the source side. But we are thinking about a new use case for the NMT system. So in this scenario, the translation is not going to be used by a human. So the final user of the NMT model is another machine. So as you can know, you know, there are systems online now which are so cheap and they can process the text and they are accessible using the online APIs. But they have some problems. One is that these systems are very limited to some languages which are high resource languages, and we don't have any access to the underlying training data, and we cannot customize these systems. So the current challenges that we have facing using the NMT model to translate for this scenario is that these systems are usually trained to do a translation that the end user is human, but now we have a machine, so maybe we should follow other goals than fluency and adequacy of the translation. So if we want to define what is the proper output of the NMT model for another machine, maybe the adequacy and fluency are not important anymore. And we want to translate the sentence in the source language to the target language by translating to something which is as simple as possible that the downstream classifier can easily process the translation. The components that we have is a classifier on the target language, which is like a black box to us. So we cannot customize this system and we don't have any access to the underlying data. We have a pre-trained NMT system using the parallel data. So it is considering the human still as an end user. And maybe we have a little amount of data labeled in the source language, which is not enough to train a classifier from scratch on the in the source language. So I'm going to talk a bit about what they did before in EMNLP 2019 to try to adopt this NMT system for this scenario. So our approach was based on reinforcement learning. So as you know, in reinforcement learning for machine translation, we have an NMT model. And based on the input sentence that we have, we sample some translation from the NMT model. And we can use multinomial sampling or beam search to do that. And then the user gives a reward for the translation that the system has done. And then the system tries to use this loss function to update its parameter. And it tries to maximize the translations which have better rewards, which are getting better rewards from the user. So to change a bit this scenario to machine-oriented scenario, we try to define a new reward for our scenario. So consider that we have a sentence in the source language, and we do the translation using the NMT model, and we pass it to the downstream classifier to do the classification. The final output that we get is a probability distribution over the labels that we have. And then since we have a limited amount of data labeled on the source sentence, we know the true label for this this input sentence, and we can use the probability given to the translation as a reward. The other thing that we did was changing the sampling strategy. In reinforcement learning, usually they only sample one sentence to update the system, but here, since we can compute the reward so cheap for all the samples that we generate, we try to do a couple of samples from the NMT model, and then we pass all of them to the classifier to do the classification. And finally, we get the sentence which has the highest reward, and we update the system with this sample. So in this case, we can maybe leverage more the rewards from the downstream classifier. So if we go to the multitask more reinforced, which is the main contribution of this paper, we are going to address different downstream classifier instead of only one. So this is helpful because it is more efficient than adapting a single NMT model for each of these tasks. So, and also we have the possibility to share the knowledge between the tasks. So there are some questions that we are going to answer. One is how to inform the NMT model about different downstream tasks, and how we can balance the importance between the tasks. So, and the last one is how to push more the NMT model toward the machine-oriented objectives that we are defining. So the first thing that we did is based on the work that has done before in multilingual scenario. So we added a token to the source sentences to inform the NMT model about the downstream classifier. So for example, if we want to translate a source sentence for a sentiment classification, we just add a token to inform the model that what is the downstream classifier. And the other thing is how to balance the importance of the tasks. So there are some works before in the literature. One is uniform sampling, which means that balancing the data between the tasks. It has some problems. One is that model usually overfits on the task with the smaller data, because by oversampling the data, the task with the smaller data, we are doing the repetition, and we are overfitting the model on that task. And we will have a performance drop on the other task with the larger data. And if we go for proportional sampling, which means not balancing the data between the tasks, it can be problematic when the data between the tasks are not balanced, and they are very imbalanced, and we will get catastrophic forgetting on the task with the smaller data. So at some point, the system usually totally forget about the task with the smaller data. We did our experiments on Spanish and Italian. This is the data that we have for Spanish. On the last row, you can see the data that we use for downstream English classifier. So we use a lot of data to train the downstream classifier system. But on the source side, we don't have too much data. It's like a couple of hundred data points for news classification and hate speech detection. Also for Italian, we have the same setting, but here we try to have more imbalance data distribution between the two tasks, and the tasks are news classification and sentiment analysis. And the baselines that we have, the one is a generic NMT system, so it's using a generic NMT system to do the translation step. The other one is the NMT system trained using more reinforced only for one single task. And the last one is just fine-tuning Mbert using the limited amount of data that we have on the source side. These are the first results that we could get. As you can see, comparing the single task with the other two baselines that we had, On the news classification, we see that the more reinforced can help the NMT model to adapt the NMT model in a way to get better performance on the downstream task. But on the other side, on hate speech, we can see that still the source classifier is working better. It can be due to the fact that here we have more data compared to the news classification. But if we come to the multitask scenario, if we go for a uniform sampling, we can see that we have under fitness on the task with more data, which means that the system are overfitting on the other task. But if we go for proportional sampling, we don't have this problem. But on the other setting that the system is, the data is very imbalanced between the tasks, we will get the catastrophic forgetting on the task with the smaller amount of data. So we thought about what we can do to do a better balance between the tasks. We try to look again to the loss function that we have in reinforcement learning. If we compute the derivative of this loss function, we can see that the reward is just like scaling the learning rate, which means that, so by looking at this, we try to define a new reward, and we did a reward normalization. So consider that we are generating some samples and we are getting the reward for all of them. So we try to compute the average of the rewards for all of the samples that we have. So if this average is going up, it means that the system is working well for that specific task. So we have to penalize more the reward. So we emphasize less on the task that the system is working well on. But on the other side, when we are getting average reward, which is not so good, it means that the system is not working well for this specific task. So with the penalizing less the reward that we have, we are emphasizing more on this task. The other thing that we did is about sampling strategy. There are usually two sampling strategy in reinforcement learning. One is beam search, which means exploiting more the pre-trained model that we have. So in this case, the model doesn't change too much its behavior, and it relies more on the knowledge that it has from before. But in multinomial sampling, because we are doing, we are adding a randomness to the system, we can explore more the probability space and getting to better translation maybe. So since here we want to really change the behavior of the NMT system to go toward to machine-oriented objectives, we also try to enable the dropout while sampling from the NMT model. In this case, we can add more noise to the system and maybe trying to pushing more the system toward the objectives that we have. So here is a comparison between uniform sampling and the works that we did. So the uniform sampling is the blue column. And when we do the reward normalization on Spanish, you can see that we don't have the underfitness on the hate speech detection anymore. So the system is working very well. And by adding the dropout, we are pushing system more toward the machine-oriented scenario, and we could get better performance compared to the other two settings. And by comparing the best performing system, multitask system, to the baselines, we can see we have improvement over all the systems. So we have the most improvement comparing to generic NMT model. Also, we could also beat the source classifier, which is a multilingual BERT trained using the amount of data that we have on the source side. And also it could beat the single task more reinforced, which means that maybe it's getting some information from the other task and it is helpful. And we can see the same improvements on the hate speech detection. And also for Italian, on the news classification task, we had the same trend. But on sentiment analysis, we can see that the works that we did, the reward normalization and enabling the dropout, didn't help, and we had some performance drop compared to uniform sampling. But by considering that we have a lot of improvement on the other task, we can say it is acceptable to have this drop on the sentiment analysis. And here there is a comparison between the other baselines that we have and the best setting in multitask. On the news classification, we could beat all the baselines, but on the other side, the single task scenario for sentiment analysis is working better than our approach on multitask. And maybe it is because of that we have a lot of data on sentiment analysis, like a couple of thousands instead of a couple of hundreds. So the multitask system couldn't reach to the performance of the single task. But this system could outperform the other two baselines. So to conclude, we could show that Morinforce successfully can extract the knowledge from downstream classifier, even though that we don't have any access to the underlying architecture or training data. And also we showed that the single NMT model can be optimized for multiple downstream tasks. And this reward normalization and sampling with dropout could outperform the previous approach that we did in both single and multiple task settings. Thank you so much for listening. So if there is questions, please.
Thank you. Let's thank the author, well, virtually. So please send your questions to the QA box. I actually have one. It's related to the sentiment analysis drop that you mentioned. So you say that it's probably because of the amount of data, but have you looked at the translations produced by both the single task and the multitask to understand what is the main difference there to see this?
There is not so much difference. Usually the system tends to translate to something which is really easy for the downstream classifier. So for the sentiment analysis, it usually tries to generate something like, I'm happy about this, I'm happy, I'm not happy. So it's really easy for the downstream classifier to classify, but sometimes it makes some mistakes. So there is not so much change between the outputs of the two systems.
Okay, so probably most of it is amount of data then.
Yeah.
Okay. So, questions? Okay, I have another one. So this whole reinforcement learning scheme, compared to the source baseline, which is, I think, fine-tuning on multilingual BERT, both the single task and the multitask, how much of added computational load you add to so comparing to the source baseline, is it much more expensive? Is it less expensive in terms of computational power that you need, or how is it? Do you have any idea about that?
About computational power, I can say that the translation system has the same cost as multilingual BERT. But the thing is that after translating, we need to pass the outputs to the downstream classifier. So it depends on the downstream classifier if it is another multilingual BERT. So it's like the cost is like double. Yeah, this is the problem of this approach, that we need to translate first and using another system to do the classification. So on the inference phase, it is more costly than source classifier.
Okay, thank you. We have a question from an anonymous attendee. He or she is asking if you explored elastic weight consolidation for dealing with catastrophic forgetting.
What approach?
It's an approach called elastic weight consolidation, and it seems that it can handle or mitigate catastrophic forgetting.
Actually, there are some approaches to dynamically weigh the importance of the tasks, but they are usually expensive to do. For example, there are some works also in multilingual NMT. So after each epoch, they try to do some evaluation and give the more weights to the task with the lower performance. But we found that reward normalization is easier for us to do because we don't need to stop the training, do the evaluation, and start the training again. So we decided to do reward normalization.
Okay, thank you. We still have time for questions. Let's see if there is. No questions? Actually, I was also wondering about the dropout and any other hyperparameter that you might have. So for example, one of the things that I guess helped getting to the solution that you are proposing for upping the multitask with the single task is the dropout at the inference time, if I'm not mistaken. So how much dropout? What's the dropout rate there? Do you need to use it a lot, high rate, or is it not so much?
No, actually, I didn't change the dropout that we usually use for training the NMT model. So it is like 0.1.
Okay. All right.
And it is not for the inference. It's when we are sampling during the training.
Okay. So, okay. Yeah, that's what during sampling. Okay. Thank you. Any more questions? Okay, we get another question here. So different tasks, it's another anonymous attendee, why did I say? Different tasks might require different types of inputs. So have you done any analysis on the impact of different tasks on each other? Is there any pattern there? Or can we simply just put all the tasks together and let the system deal with them? Do you have any idea about that?
We didn't try. Actually, it's not easy to find data sets to try with, different languages than English. So it's not easy to find tasks. So if you know any data set that we can use to do the comparison, they are welcome. So let me know in the Slack. But no, unfortunately, we didn't try with other settings here.
Okay, thank you. All right. I guess we can thank the speaker. We still have some time for questions if anyone has more. Otherwise, we can wrap up and wait a little bit for the next presentation. Okay, no questions. So thank you, Amir-Hossein.
Thank you so much.
The presentation and all the questions. Oh, okay, a question just came in. Okay. Do you want to answer here, or well, I think we have time. Can't we simply take the data sets available in English and empty them into the target tasks and then treat them in the similar way that you have done here?
If I understand correctly, it means that we have the access to the English data, right? In English.
Yes.
But we consider that we consider the downstream classifier as a black box. So it's like we have already trained a classifier on the target side and we don't have any access to it. So yes, if we have access to the English data, so we can do a lot of things and do a lot of comparisons, but we consider that the system is already trained and we don't know how it is trained. So is it possible to extract some knowledge from this system to the low resource languages or no?
Okay. Thanks a lot. Thank you again for your presentation and all the questions that you answered.
Thank you so much.
So do we have the next presenter? Yes, okay. So the next paper, the title is Double Attention Based Multimodal Neural Machine Translation with Semantic Image Regions. I guess we are going to wait a little bit, just 1 minute. So if anyone wants to tune in sharp at noon. But I already tell the name of the authors the best I can. So I think the presenter is Yuting Zhao, and the work was also by Mamoru Komachi, Tomoyuki Kajiwara, and Chenhui Chu. So just 1 minute and we can start. I think everybody can see the screen, right? I can see, so. Okay, the floor is yours, Yuting.
Okay. Hello, everyone. Welcome to my presentation. I'm Yuting from Tokyo Metropolitan University. My research topic is double attention-based multimodal neural machine translation with semantic image regions. Firstly, I want to introduce the background of multimodal machine translation. Why people use multimodal machine translation? The question is semantics still poorly used in text-only machine translation system. We can understand from an example on the English to German tasks below. We highlight the words that distinguish the results. Green words are marked for better translation and red words are marked for worse translation. If there is no image, text-only machine translation will translate the word which means rock to a German word which means stone. On the other hand, the difference between stone and rock can be directly recognized by considering the image information. So this is the reason for incorporating image to text-only machine translation. It is called multimodal machine translation. This part, I want to introduce some related works. In the previous work, there are two forms of visual modality integrated into multimodal machine translation. One is global visual features, the other is local visual features. For global visual features, the visual feature is extracted from a whole image as a vector. Local visual features are divided into two categories: the equally sized grid visual features and the semantic image regions. Some previous work extract some uniform grid image regions by a convolutional neural network called CNN. For some other work, they try to extract object-level image regions from an image by object detection method. Among the previous works, I want to introduce two in this part. For the first one, this research integrates global visual features from whole images into the multimodal machine translation system. They incorporate global visual vectors to the height, and detail of the source sentence. On the other hand, they incorporate the global visual vector to initialize the encoder or decoder hidden states. Also, their method outperforms the result of neural machine translation. However, the whole image vectors do not contain detailed visual features, so that the image's effect has not been used enough. For the second previous work, this is research that integrates images into multimodal machine translation by extracting 196 equally sized grid visual features. They proposed a multimodal attention mechanism which incorporates the grid visual features and the source textual features to a multimodal context vector by the multimodal attention mechanism. As grid regions do not contain semantic visual features, so the multimodal attention cannot capture the useful visual information from the equally sized grid visual features enough. According to the previous research, we propose our model as the overview on this page, which uses the semantic image regions. As shown in overview, for improving multimodal neural machine translation's visual quality, we use object detection to extract the semantic image region visual features instead of equally sized grid visual features or global visual features extracted by CNN. Furthermore, we take advantage of double attention for the integration, one for textual features and the other one for semantic image region features. And our method has 0.5 and 0.9 blue scores improvement in English to German and English to French tasks. In this section, I will introduce our method in detail. This is our model. It consists of 3 parts: the source sentence size, the source image size, and the decoder. For the source sentence size, it is a normal attention-based neural machine translation system. Firstly, for the source image side, we extract 100 semantic image regions by the method of fast RCNN in conjunction with ResNet 101. Then we utilize soft attention to selectively attend to 100 semantic image region visual features to calculate an image context vector, ZT. When generating the decoder hidden states, ST, 4 factors will be considered. They are the text context vector, CT, the image context vector, ZT, the previous hidden states, ST-1, and the previous target word, YT-1. Next, I will explain the calculation of the 4 in detail. In the source sentence side, the text attention mechanism calculates a text context vector by considering about encoder hidden states HI and the proposal hidden states ST herd. Among it, the ST herd is calculated in the decoder, which considers about the previous target word and the previous decoder hidden states at first, and then used in the following calculations. In the source image side, firstly, 100 semantic image region vectors are extracted by fast RCNN in conjunction with the ResNet 101. And then the attention attend to all the semantic image regions to calculate the image context vector ZT. For calculating the ZT, the attention considers about image region vectors and the proposal hidden state ST herd to calculate alignment model ETS and the weight matrix alpha TS. Additionally, at each decoding time, step t, a gating scalar bit t from 0 to 1 is used to adjust the proportion of the image context vector according to the previous decoder hidden state st minus 1. The decoder is a RNN with conditional gated recurrent unite called CJRU to generate the current hidden state ST and the target word YT upon two attention mechanisms. In the decoder, for generating the decoder hidden states ST, the model considers the text vector CT, the image context vector ZT, and the proposal hidden states ST hard, which is calculated from previous hidden states and previous target word. For generating the target word YT, the model uses a nonlinear function by considering the ST, CT, ZT, and YT minus 1. For the data size, we use English to French and English to German data size of multi-30K. In this data size, each image is paired with 5 image descriptions in multiple languages. For baselines, we choose 2 baselines. One is text-only attention-based neural machine translation model called OpenNMT. It consists of a 2-layer bidirectional GRU encoder and a 2-layer conditional GRU decoder with attention. The other is double attentive multimodal neural machine translation system. It consists of a 2-layer bidirectional GRU encoder and a 2-layer conditional GRU decoder with 2 attention mechanisms. Well, in this research, they use 49 equally sets the grid Whistle features by CNN for experiments. For experiment sightings, we cite parameters as displayed, such as we set image region drop-off with 0.5, and we run 25 epochs for running, and the dimension of encoder decoder hidden states is 500, and the batch size is 14, beam size is 5, and so on. For the evaluation, we utilize 2 metrics, the blue and the meteor on both translation tasks. This is our results. The first line is the blue scores on both tasks, and the second line is the meteor scores on both tasks. Comparing with the text-only neural machine translation system, for English to German tasks, our model improves blue scores by 2.3 and the meteor scores by 2.1. For English to French tasks, our method improves blue scores by 1.6 and the meteor scores by 1.1. On the other hand, comparing with W-attentive multimodal neural machine translation system baseline, for English to German tasks, our method improves blue scores by 0.5 and meteor scores by 0.4. For English to French task, our method improves blue scores by 0.9 and meteor scores by 0.8. In the analysis section, we firstly do a pairwise evaluation of translation manually. Then we do a qualitative analysis by visualizing the semantic image regions paired with translation examples. In the pairwise evaluation part, we randomly evaluate investigate 15 examples on English to French task to do a pairwise evaluation. As shown in the table, we statistic all the samples in the investigation into 5 categories. We can see like there is 48% of examples have better translation performance than both baselines. On the other hand, there are also a few translations that have been worsened. So we visualize the semantic image regions with the translations for further qualitative analysis. Firstly, let's look at 2 examples of semantic image regions that improve translation performance. We found like the semantic image region feature include the object attributes and the sense understanding, which may help the model perform a better translation on the verb and the noun. For the first one, we can see like our method is better at translating the verb grabbing compared with both baselines, owing to the semantic image regions. For the second one, our method is better at translating a noun, owing to the semantic image regions. When the target word terrier was generated, the attended semantic image region at that time step provided the exact object level visual feature to the translation. Of course, our model still have shortcomings. Let us look at 2 such examples. One is the image attention mechanism does not work efficiently. The other is the visual feature quality not good enough. We can understand from the 2 examples respectively. For the first one, although we improved the translation of the verb of happily, but the attention cannot attend to the most appropriate semantic image region. Since the semantic image region may not contain clear semantic information, the translation performance does not benefit from the region feature exactly enough. For the last example, both shortcomings have been shown. To conclusion, we proposed a model of multimodal neural machine translation that integrates semantic image regions with double attention mechanisms. Secondly, experimental results show that our proposed method outperforms both baselines. Thirdly, we also demonstrated concrete improvements on translation performance benefited from semantic image regions. At last, we also analyzed our method's advantages and shortcomings. In the future, we aim to integrate stronger attention function for attending to the more specific semantic image regions. Thanks for listening. Thank you very much.
Thank you, Yuting, for your presentation. So do we have questions or any clarifications that people want to make? Please type in the QA box if you do have them. We have plenty of time. Meanwhile, I have one question. So you are using an object detection classifier, so a model that tells what is the object in the image, right? Mm-hmm. How good does this model needs to be in terms of accuracy? Did you take it out of the box, or do you have an idea about how good it was before using it?
Okay, I think we used the object detection method with fast RCN, and this method will extract 100 semantic image regions automatically, and this semantically image region features will be extracted from pre-trained fast RCN by Visogonal that dataset. That dataset provides a lot of object attributes and object concepts and a lot of region feature types. So we use the faster RCN to extract semantic image region directly, not anything else for fine-tune and something else.
Okay, thanks.
Thank you.
We have one question. Given that you have descriptions in multiple languages, have you experimented with multilingual models?
No. Just for the English to German and the English to French tasks, not reverse or for any else multilingual trying.
So you had bilingual models, right? Bilingual plus the modality of the image. You didn't try putting together these two languages, these three languages, and plus the image.
Use the dataset multi-30K, which is English sentence together with image, and based on it, multiple languages translated from the English description. So at last, we get the dataset that English paired with multiple languages and paired with image together.
Okay, thank you. Any more questions for the author? I have one more that is related to the evaluation that you show, in which you do the analysis for the output, how the output changes with the system that you proposed. So the changes that you observe in your system are more related to nominal expressions or verbal expressions. So they are more related to actions or to actual adjective, nouns, and so on. Do you have any idea about that?
I think maybe when the image box contain the information of noun, it will help put the translation performance of a noun better. But on the other hand, if the image region contain the sense attributes, for example, the boy doing something, or the boy doing something or have something in his hand, this things attribute will help the verb translation better, I think.
Okay, thank you. Do we have any more questions? If you don't have questions here, you can always write on the research track channel in Slack or contact Eamt directly. So if we have no more questions, I guess we can wrap up a bit earlier. given that this was a session with 2 papers only, maybe we can go for the lunch earlier. Okay, let's thank Yuting for her presentation and for the questions. Thank you.
Thank you very much.
Hi, Mara. Hi, Lena. Hi, Mara. Yes, I don't know which one is going to present, to make the next presentation.
Hello there. Mara's going to be the main presenter, but I'm always here if need be.
Okay, so you are going to, I'm going to keep you both as panelists, okay?
Great. Thank
you. Perfect. You're welcome. Do you want to share screen? If you want to share screen, just try it now.
I'll see.
And let me see if I should do something. I think
I'll let Mara share screen.
Okay. Okay.
Oh, she's already in here.
I think only Mary is missing. I'm going to check her in the attendees list.
Okay, hello everyone. Welcome back. We hope you had an enjoyable lunch and you're ready for an action-packed afternoon. We're going to kick off with our final user track presentation, after which we will turn it over to the translator track. I'd like to welcome Mara Nunciatini, who will present WeLocalize's presentation on their different levels of post-editing they're using and how they are negotiating that. So I turn it over to you, Mara.
Hello, do you hear me okay?
Yes, we
Cool.
hear you. Yeah.
Right, so welcome everybody to my presentation. This is Mara speaking. I am AI Program Coordinator at WeLocalize, and I wrote this paper together with Lena. She is my teammate and she is with me today. And for those of you who don't know us, WeLocalize is one of the largest LSPs, language service providers, and we have more than 30 customers with machine translation programs currently ongoing with different levels of post-editing, light, medium, or full. And based on our experience, we have noticed that it is very difficult sometimes to communicate to the linguists what is expected of them in different levels of post-editing. So we decided to write this paper, and today we are explaining why we think that there is a gap between the post-editing in theory and the actual requests that we receive from the translation buyers. And we also want to explain the workaround that we have found to bridge this gap. So the first part of the paper is actually an analysis. We analyze the existing definitions and standards for light and full post-editing. We chose ISO, GALA, TAUS, and Sharon O'Brien standards, and we referenced the DQF MQM error framework to compare them. So as you can see in this screenshot that I took, this table is actually in the appendix of the paper, so you can have a look at it. You can see that we have the high-level error category on the left, and then the granular error typology in the next column. And the exercise we did was to take notes of what every standard said about, every granular error type. As you can see here, there are some granular error types that are not covered by the standards. And for some others, each standard is saying something slightly different. So what we have noticed during this analysis is that the definitions are not always precise, and the guidelines are somehow vague for a post editor to implement when it comes to hands-on post editing. And of course, these guidelines are still super useful, and probably these were intentionally left not really granular enough, because these, of course, would have to apply to different domains, different content types, and so on. We also noticed that the nomenclature sometimes is inconsistent, sometimes the nomenclature is overlapping, and there are gray areas that do not fall either into light post editing or, as we have seen in this example here, are not covered. Also, one important thing for the translation industry is to know how many linguists should be involved in each level of post editing. For example, how many people should be involved in full post editing and how many people should be involved in light post editing. Normally, the translation buyers are used to buy a process rather than a quality level. Also, we have noticed that there is a misunderstanding out there. Sometimes people tend to think that the post-editing level is not describing the final quality level of the post-edited file, but rather the effort of the post-editor. And of course, this is not true. For example, if we have to post-edit a file, a technical document, let's say I'm just making up an example, into Spanish and into Finnish, for example, we might think that because the machine translation output for Spanish is normally better, then for Spanish, we can have just light post-editing, while for Finnish, because normally the machine translation output could be a bit worse compared to Spanish, then we would have full post-editing. Of course, this is not the case. If we want to have full post-editing because we want top quality, let's say, we should have full post-editing on every language. And then, of course, the effort of the post-editor would change. In this slide here, I am showing the analysis that we did in more detail. So we are seeing what the standards are saying for every level of post-editing. For light post-editing, for example, we have noticed that there is a common agreement. The aim of light post-editing is to convey the meaning of the source in an accurate way. So if we had to reference the GQF MQM table, like we said in the example before, we could say that the accuracy error types would be in scope for sure, but not style, for example. And there is something that is not totally clear from the guidelines. Is terminology in scope? Spelling and grammar are in scope, and until what extent? This is a screenshot of the table that we prepared for light post-editing. As you can see, O'Brien is, of course, commenting on some of the issues, but some other are not commenting on every issue that I am showing here. And on the other hand, for full post-editing, we have seen that the common agreement seemed to be that the focus should be placed on readability. So again, if we had to reference the GQF NQM table, we could say that accuracy, fluency, and terminology checks are in scope. However, is style in scope? Does the translation really need to be like human quality, or is some deviation from style allowed because we are doing post-editing and it is not really a human translation? This is not entirely clear. And medium post-editing is even more controversial because this post-editing level is mentioned sporadically in the literature, and there are no definitions that we could quote here. And the guidelines from the language services providers are, always different. So we at Relocalize, we would expect that the post-editor would put more effort into editing the terminology and the fluency compared to light post-editing, but not to the extent of full post-editing. Here I am explaining our workaround. So rather than relying on the vague definitions and guidelines for post-editing that are most popular and commonly referenced, we would define the quality requirements for each translation request. So, for example, we would consider the purpose of the document type, the target audience, as well as other items. And based on those, we would have the client decide which error categories are acceptable, if any, and which are not. And we would note them down in the GQF MQM error matrix framework, like in this example here. Here we were preparing a list of quality checks in scope for a translation job, post-editing job. And here I just chose to show you that terminology was in scope, while style was not in scope. So once we have prepared this list, we share it with all the translation process stakeholders, so the client, the post-editors, and the reviewers. This way, we are able to get full consistency as for quality requirements from the start until the end of the process. And of course, we have seen that, even with this strategy, we came across some challenges, both on the client side and on the linguist side. As for the clients, we have to remember that they are not always familiar with the error typologies, with the quality assurance methodologies, And therefore, it is very important that we support them, we guide them, and we give them advice on what post-editing level we think is more appropriate to reach their objective. And on linguist side, sometimes we have found that experienced post-editors and reviewers find it difficult to understand that for certain jobs, certain requests, it is okay to leave certain issues unedited in the machine translation output and accept that ultimately their effort really depends on clients' quality requirements. And here I put some examples for you, some use cases. In the first one, we received a request from a customer. They needed to translate a big amount of low visibility backlog in a short time and within a limited budget. Normally, of course, we would think straight away of light post editing for this kind of requests, but the client had an extra requirement. All the product names should stay in English. And of course, then we had to think of another solution, which was light post editing plus a DNT check. And it was very important that we made it clear with the post editor, because normally with light post editing, we would think that you do not have to pay a lot of attention to terminology. The second use case, we received a request from a client to translate online help content with medium post editing. And for this content type, it is usually okay to have medium post editing because the linguist, of course, should focus on accuracy, because the user must be able to understand the instructions and implement the instructions correctly. However, style is not really a key aspect. And this client also had an extra requirement, which was to have formal tone of voice. So as we said, normally for medium post editing, we would not pay attention to style. However, in this case, we had to ask the linguist to perform medium post editing plus a register check. And the last use case is, we received a request to translate UI and UA content. As I said, for online help, with this content type as well, we would normally pay attention to accuracy, but not that much on style, because the important thing is that the user is able to follow the instructions in the document. However, this client was really wanted to see the brand style reflected in the document, and also they had a lot of preferred terminology. So the amount of effort, the extent of the effort of this post editor was so big that in the end we classified this as full post editing. Right, so this is the last slide. There are also another couple of things that we like to do. The first one, we like to make sure that the post editor, the effort of the post editor is adequate for the quality level that the client is requesting. And how do we check it? We would check that the post editor is not over editing and is not under editing. So for example, if we see that a project has an especially high edit distance, and we would recognize it because after every project, we analyze the edit distance with our internal scoring tool, we might think that the post editor is over editing. So we would analyze the changes introduced, especially in those segments with higher edit distance, to find out where the post editor is putting most of their effort. Then we would investigate if the changes introduced are actually necessary to meet the required quality level. On the other hand, if we notice that there is a project with an especially low edit distance, we might think that the post editor is under editing. And then we would check closely the quality of the translation, maybe even, set up an extra LQA check. And we would pay special attention to unedited segments to make sure that they were actually okay as they were and they didn't need any edits. If we find quality issues, then of course we would follow up with the post editors, maybe by providing them quality feedback or also organizing extra training. We also think that it is very important to provide guidance and set expectations both on the client side and on the linguist side. So on the client side, as I said, it is very important to understand their quality requirements, provide them guidance and recommendations around the right post editing level. For example, one way that we have of doing it is organizing pilots. We can translate the same document, both with medium post editing, for example, and full post editing. And then we would show the client the two different final translations. So the client can decide which document is more adequate to fulfill the requirements. It is very important that we help the client achieve the cost saving that they are hoping to see, but also the quality that they are hoping to see. On the other hand, linguists, we found that it is very, very useful to have a meeting at the start of every engagement. We normally have onboarding calls where we explain the linguist the project, of course, the quality level that the client is asking for. We explain the type of machine translation engine that we are using, how and if it was customized, what are its strengths, its pain points, and what kind of mistakes, of course, they should be looking for and fix. And as I said, we always monitor the performance and check for unexpected behaviors. Wow, right on time. So I hope you found it useful, and thank you very much for listening to me. And I was also very, very curious to know if you had maybe similar experience.
Okay, thank you, Mara, for that presentation. Now I'll open it up for questions, and Mara will be answering, but also Lena Marg, the other author of the paper, is here to answer questions. So let me start with these, and remind me at the end to re-ask your question, Mara, about if other people have this same experience. Right. Yeah.
Cool.
Okay, so to start it off, to your knowledge, is there a high demand for light post editing, or do you think this category is disappearing?
No, there is. Yeah, there are different clients that are using are requesting light post editing. Mainly, as I said, is to translate big amount of content or backlog that maybe normally they would not translate, or maybe because they are required by law to translate something, but this content maybe is not really highly visible. So for these types of content, we get requests for light post editing.
I would also add that I think, I think user reviews, which have been discussed in this conference several times, kind of are a funny one. They tend to initially start with raw MT, but very often there is then an element for user reviews that haven't passed a certain threshold to then be, geared towards light post editing or something. But I agree with Mara, it's definitely a growing area, if anything, I would say.
All right, next one. Does it ever happen or make sense to replace full machine translation and post editing with human translation? So do you see that happening, that you're offering full PE, but then it makes more sense to just have human translation, so you advise clients to do that?
Yeah, I think we saw a couple of times that for marketing content, meaning more creative marketing content, we found that full post editing was not really delivering the right quality level. And I think in the end we dropped post-editing, but maybe Lena, you remember something else?
Yeah, I guess it's a slightly more tricky conversation because it involves it's not just about it involves again also very often the client expectations, onboarding. I was sort of thinking about the question. I think what we're trying to do very often as well is a full post editing should meet the quality expectations, but of course there might be some languages on a huge program where it really doesn't work. You can't effectively do post editing and meet the quality and be more productive. So we definitely have those conversations on the basis of individual languages where we see it's not working out. I wouldn't say we have them on a program level because that conversation happens right at the start. So if we see it, we do a content type analysis and the content is not suitable for post editing, then we wouldn't even go down that route. But once we've agreed with the client that we think it's suitable, we will have always done some testing already at that point. We will normally stay with the bulk of languages at least with that process, and then there might be the odd language that we decide it's just not working out and we're going back to human translation. But yeah, like I said, it's a more complicated conversation to be had at that point in time very often.
Okay. And what about the proposal to use post-editing and machine translation? Is it the client that comes to you and says, we're interested in this? Or is it more that you are guiding clients and asking them if they would be interested in that?
Again, that's a very, both happen. So we will have, I guess, very mature clients that, themselves are very interested in this area or propose this and we work together on that. Or we will have clients where we think that they might meet their targets by introducing machine translation. So the conversation can be initiated by both sides, really.
And which do you see more often? This is another question. Do clients want machine translation because they want to reduce costs, or is it more about speeding up the translation process?
Most of the time it's cost, but process it's always been a factor as well. So that does keep coming up as a requirement. But again, it depends on industry as well. So especially the very fast turnaround industries, of course, that we've had conversations with gaming, for example, where that is critical. So we reduce turnaround times, but I would say mostly it's cost, for sure.
Okay. Which QA tools, I'm assuming it's in the CAT tool, do you use to check for these project-specific requirements? Is there ever any disagreement with the client on whether they have been met?
We use a lot of tools. So depending again on the client, we work with different CAT tools, different quality processes, and normally the whole quality, control aspect is managed by the quality team in our organization. Yeah, I mean, I think it's very common to have discussion with clients about, in any kind of with human translation or machine translation in the process as to whether something should have been penalized or not. So yes, there are discussions, and Mara was, I think, alluding already to that we're trying to guide clients in these conversations around what error categories we think might be relevant for their content type and translation purpose. But it's, again, we're saying the client as if it's one person. Very often you've got a whole group at the client, at the buyer side, different stakeholders from quality departments, from technology departments, and they have different interests in this conversation as well. So that conversation is not necessarily that straightforward. So it's very often a sort of a lengthy process of getting from the first kickoff talk, exploring, doing pilots and tests, going live, and then seeing if we have to kind of renegotiate or reassess what we're doing, and if maybe some errors that we thought weren't so critical in the end maybe should be kind of added to the map. So that happens as well.
Okay, a few questions on pricing. How would you estimate the time cost difference between full PE and human translation on text with high quality requirements, such as legal or technical?
I don't know, I've been out for a while. I doubt anything massively has changed, Mara. But again, depends hugely on language, of course. You know, that's anybody I think at this conference will appreciate that. So we are very often having programs with more than 10 languages involved, very often up to 40 languages. So obviously there's variation in there. Some languages, you know, will easily save you double their throughput basically, but other languages will only, you know, improve productivity by 10%. So there is a wide range of productivity gains in there. It's difficult to answer for across the board, I would say.
Okay, and then while we're on the topic of pricing, do you adjust the pricing of the project based on what the specific errors are included for post-editing? If so, does that add a lot of complexity to the pricing strategy, or would you say it's worth it?
So, I mean, initially, of course, so there's definitely different pricing for the different levels. You know, if you have full post-editing, medium, or light, that's the first sort of roster, I would say. And then yes, we're trying to, and I guess this is ultimately, I think, where everybody in this industry is trying to go, or, you know, like having CAD tools that automatically tell everybody what the edit distance was and having it on a segment level, and then maybe kind of, you know, basing pricing on that. We've got some clients who are doing that already, where everybody sees exactly, you know, the translators can see how much effort has gone into the task, the buyer can see it. And so I guess that's possibly the most transparent or fair pricing. And because it's built into the tool, it's easier to manage. But yeah, we try to adjust. But again, you know, that's not something that is easily done, like happens, you know, it's a longer process. And yes, it does add complexity, of course.
Yep. Okay, a few questions then about the checks that you do. The first one, how was the do not translate check done? It was in one of the examples.
Yeah, we basically share with the linguist at the until list that they could add to their you know, term base on their CAD tool. So the QA check, of course, would tell you if a term of the glossary was followed or not.
Okay. Did I understand it correctly that you are measuring edit distance for every post-editing project? If there is an over or under editing, you correlate it to the final quality of the post-edited output, but isn't it an assessment of your MT engine?
We don't assess every project, no. we're a limited team as well. Yeah, no, we can't assess every project. And again, you know, there's so much, like some tools would allow us to, you know, do this on an ongoing basis, and we could just tap in as and when we need it. Most of the time, that's unfortunately not the case. So it still remains a very manual task very often. So let's say we'll internally, or, you know, with the client, depends, but very often internally just agree checkpoints. So we think certain languages need more monitoring, or, you know, whatever the reason behind it might be. And then, yeah, so for example, for one of the light post editing clients, what we did is look at the edit distance, and, you know, you get a trend. I guess very often, I think with any kind of metrics or measuring, it's about monitoring trends, you know, human or automatic metrics. And then if we see, okay, this is a good edit distance for this project. We know that with this edit distance, roughly for each language, we're hitting the quality expectations, and that's been confirmed by quality assurance checks. So if we monitor that and we think everything's fine, that's good. But if we see something dropping, then we'd be concerned and say, okay, there's something doesn't look right. Then you dig into it, you do a root cause analysis, you know, what's going on. And then if we find, you know, that there's in that quality assurance check, you know, something, it has been flagged up, then of course we can correlate the edit distance and that quality assurance check, and it's a great way to have a conversation with the translation team, and anybody who, you know, kind of needs to know what happened, why that mistake was made, basically. And yes, of course, it also tells us something about the MT engines, obviously, that as well. But yeah, but it does give us a very good insight into post editing. To be honest, we've done it several times now, and it is very, very useful, we've been finding.
Okay, great. There were a few questions that were unanswered, but some had, I believe, were answered anyway within the answers to other questions. But if anyone has leftover questions, go ahead and put them into the user track channel in Slack. And sorry, Mara, we didn't get to ask other people what their experience is, but that could also go into the user track channel of
Yes,
Slack.
of course.
So,
Thanks.
yep. All right, thanks very much for your
Thank
presentation.
you.
I am going to turn over this chairmanship or chairpersonship to Joss. I see you here.
Well, actually, it's going to be me to present this first paper.
Okay, yeah, I didn't see you among the row.
Yeah, I
of
was
people.
hiding.
Oh,
I was hiding. So welcome everybody to the translators track. And the way this is going to go is that we have some longer presentations and some short presentations, but we are all going to stay in the same place. So if you want to see all the posters and all the presentations, you can stay on this track. So our first panelist, I'm very pleased to present from Ireland, Megan Dowling, that is going to present the work that she has done with Sheila Castillo, Josh Morkens, Teresa Lin, and Andy Way on human evaluation of SMT in this very nice language combination, which is English to Irish.
Hi, thank you. So I'll just get my screen shared. Can you see that okay?
We can indeed.
Okay, good. Okay, yeah, thank you very much for the introduction. Hello from Dublin. So I'll be presenting a human evaluation of English-Irish statistical and neural machine translation. And this work was done in the ADAPT Centre in DCU. So just to give you an outline of my presentation, I'll just speak a bit about the background of Irish and Irish MT. I'll talk briefly about the MT system setup, and then more in depth about the study methodology and the setup, and results and analysis, and then give some conclusions and future work. So firstly, the background. So you might recognize this image from my 2-minute pitch that we uploaded a little while ago. So some quick stats about the Irish language, or An Gaeilge. So it's a minority language and a less resourced language. But despite this, there are over 1.7 million speakers in the Republic of Ireland alone. It is an official European language and the first official language in the Republic of Ireland. So this lends itself to a use case in professional translation, both at a national and European level. So a bit of background on Irish machine translation and post-editing background. So yeah, I've said that it is used in post-editing environments and a national EU level. So there is a demand for specifically English to Irish machine translation is usually the direction that it's done in, particularly the Republic of Ireland. The vast majority of Irish speakers are also English speakers as well. There is currently a derogation on Irish language production in the European Union. So this means that only a small percentage of texts are translated to Irish within the European Union, but this is lifting very soon, 2021. So there's already this demand for English-Irish machine translation and English-Irish translation in general. So this is obviously going to increase once the derogation is lifted, and a lot more translators will be needed to meet this demand. So in terms of machine translation itself, until recently, statistical machine translation was outscoring neural machine translation in terms of BLUE specifically. But all of these experiments were reported through automatic metrics, or say a brief linguistic analysis, maybe just comparing one sentence from outputs. So hopefully this slide makes it clear that there is a real need for a human evaluation study for the English-Irish pair. There hasn't been one published before. And so with English-Irish machine translation, the use case of it as a post-editing tool, both the European and national level, will then obviously we should, where possible, be evaluating using human evaluation as the people who will actually be using machine translation. And so I'm briefly going to talk now about the setup of our machine translation systems. So I said before that it has a use case in public domain. So that's the public admin domain. So that's where our test data comes from. So 1,500 sentences from the Department of Culture, Heritage and the Gaeltacht. And much of our training data comes from this department, as well as other public bodies and European related projects as well. And so for fairness sake, we use the same training and test data for both statistical and neural machine translation. And in terms of the parameters themselves, so the SMT parameters, we use Moses and we train a 6-gram language model with KNLM. And in terms of neural machine translation, so these kind of look like fireworks, but they're supposed to look like neurons, or supposed to be neurons on the right-hand side. So we use OpenNMT with the transformer architecture and the parameters that are recommended by Vaswani et al. So using the in-domain test set that we have, we got a few automatic evaluation scores for these systems just to have an idea of where we stand, and so we can compare them later on. So you'll be able to see, so bolded are the highest scores, but I don't have arrows in this, but with blue, the higher it is, the better the score is, and tear is the lower the better, CHRF is higher the better, and character is lower the better. And so you see we have a mixture of metrics here, including some character-based ones, because Irish does have inflection in the language. So we wanted to see what a character-based metric might come up with. And you can see that NMT scores better in terms of SMT, but there really isn't too much in it, particularly character, very, very close between the two. So with SMT and NMT being seemingly on a level playing field, well, this is where we wanted the basis of our human evaluation to explore differences, comparison of SMT and NMT for Irish. So the study methodology itself and the setup. So we used 4 participants, and it was important for us that this would match the profile of intended users, and that's professional translators. So we used, there's a first Naguelga accreditation for professional translators, and they publish a list of translators. So we used this to recruit 4 participants. Before starting the study, we also did a pilot study with 2 Irish language linguists, and this was really useful for us in terms of our instructions, which were in Irish, just getting them, getting immediate feedback on the setup and changing our instructions so that they were more clear. Another thing that was important to us, so the instructions were in Irish, but also all correspondence was through Irish as well. So I think for legitimate English to Irish, where the output would be in Irish, it was important that the instructions be in Irish. We used the post-editing tool known as PET to collect post-edit information from the participants, and we also included a survey as well. So not just to gather temporal effort or keystrokes as in the PET tool, but also to get specific expertise self-reported by the participants themselves as well. So this is a diagram of the setup, and it's not to scale. So we had 4 participants, as I said, so 2 participants took setup A and 2 participants took setup B. So we used data from our test data, but first 10 practice sentences that we don't use in any of the results, just so the translators could get more at ease with the PET environment. And then 2 translators would have the first job, which had been edited by SMT, and their second job that had been post-edited by NMT, and the reverse for the 2 participants using setup B, and they weren't told which was SMT and which was NMT. We also included a survey in our study. So we gathered information about each translator's experience in years, months and years, if they had experience post-editing machine translation, which job was more fluent, more accurate, and which would they prefer to edit as well. And also a text box for additional comments. So there were only 4 participants, so it wasn't a huge amount of text to go through, and it was nice that they all gave a few comments in the text box. Yep, so now I will move on to the results and the analysis of all the data that we collected. So in terms of experience of participants, so you can see it ranges here from 5 years to 25 years. And the asterisk on the 10 years is that it's in a part-time capacity. And in terms of post-editing experience, it was 50-50 whether or not the participants had any post-editing experience. So participant 1 and participant 3 didn't have any post-editing experience. And the results in terms of fluency, preference, and accuracy. So for these pie charts here, the blue is no difference and the yellow is NMT. And you can see we didn't need a color for SMT because none of the translators chose SMT for any of the questions. So for example, fluency, the question was, which output did you perceive to be the most fluent, or something along those lines? Output A or output B, and then, or no difference. So you can see that in general, no difference, I guess, is the winner across the board, but leaning towards neural machine translation. And in terms of the comments that they shared themselves afterwards, these vary a lot as well. So there's some quite positive ones, that it's a very useful tool, or a bit more cautious with the second one, that I think it depends very much on what the machine has fed, and improving constantly, but insufficient at present. And then there was one at the end, a little bit more negative. It's not much use for English to Irish translation. It would take the same length of time to translate from scratch. So you can see it's varied across the board. What we did find interesting was that those with post-editing experience had the more positive comments than those without post-editing experience. So the PET results themselves, so this is quite a big in-your-face table, lots of information. So I've just picked out one participant to discuss. So we have the average time per segment, the average keystrokes per segment, the average unchanged segments, and the H-TER score as well, the human TER. So in this, the participant across the board in the survey said that there were no differences between SMT and NMT, or well, not knowing that they were SMT and NMT, but between the 2 jobs, that they thought there was no difference in terms of accuracy, no difference in terms of fluency, and in terms of their preference, there was no difference as well. But these don't match up with the scores that we gathered. So you can see it's highlighted in yellow. I don't know if that helps too much, but in the average time per segment, there was less time taken in SMT rather than NMT. And actually the only score gathered that actually matches the survey is the H-tear, where there is no difference. So this was interesting for us to see, but across the board there are like huge differences as well. So this is a bit of output from the 2 MT outputs and the 4 post-edited outputs. So this was just an example that we found interesting, where all 4 participants post-edited the output in 4 totally different ways. So the input is if you have been allocated as a decision maker, and just to note that the SMT output doesn't make grammatical sense in this example, the NMT one does, but even still, there's 4 different ways that the participants post-edited the output. And I think this just speaks to the nature of natural language, that obviously these are 4 professional translators. I'm an Irish speaker as well, so I can see that all 4 outputs are correct, but they're all different. And even there's not one single word that is common among all 4 outputs. This is another example from the post-edited output. And this is something that I was a little bit surprised at. So in the source, it has in the FOI legislation, which is freedom of information, but both MT systems expand the acronym in the output, and almost all of the participants do as well, apart from participant 3. So I think this shows the importance of domain knowledge. So where, for example, an acronym might be well known in one language, but perhaps not in the other. So the acronym is expanded in most cases in Irish. So this shows the importance of domain knowledge, especially in a domain such as public administration. And so in terms of some results and conclusions, I hope you've seen that the results vary from translator to translator a lot. In general, from the survey, it seems that it's no difference with a lenience towards neural machine translation. And we've seen that self-reporting doesn't always match automatic results, for example, temporal effort. In this study, we've seen that H-tear metric matches closest, but we will say there were only 4 translators in this study. We can't generalize over all Irish translators or over, machine translation as a whole. It's 4 translators, but yeah, not to generalize too much. So in terms of future work, clearly with the results that we've seen, if there was a developer choosing between NMT and SMT, we would recommend NMT over SMT, particularly based on the participants' survey results. And we would love to do a more in-depth study with more participants and perhaps a more fine-grained analysis. And then finally, it's important to mention that the derogation is lifting next year. So this creates a greater need for English-Irish machine translation with the end user in mind. So, Gurb Magwev, obrigada, thank you.
Thank you, Megan. Before there is a question here, but I think this question was from the previous panel about how useful the edit distance was for measuring. But I wanted to ask you, while people maybe start asking questions, I wanted to ask you if you had, after the post-editing, if you look at the quality, the final quality by the post-editors or translators in this case.
If I myself had looked.
Well, not you, but if you evaluated the final quality to see, you know, if it was a good quality, if, you know, if you, for example, posted it NMT because it's more fluent, are you more prone to leave errors behind? That type of analysis, you know?
No, we didn't. We didn't do that. I mean, I picked out a few examples, and I picked out a few more to kind of get a better understanding of what was happening, what kind of post edits they were made. I guess I didn't really think to check the quality of it, because, you know, we used 4 professional translators with a fair bit of experience behind them. But no, that'd be interesting to do in the future, especially with the results kind of leaning towards NMT, to see, are there actually any errors, particularly in the NMT output. So that could be another venue for future work.
Yeah, maybe also to see if the people with more experience leave more things unchanged. That could also be, right? So I have a question here from Mary Nurminen, our Mary. And she says, you said that more Irish translators will be needed very soon. That's good news. What kind of rise in need is predicted? Are there enough translators right now, or will there be a lack of them?
Yeah, I don't have specific statistics, but absolutely there will be a huge increase, and I personally don't think that there will be enough translators to meet the demand. There is, maybe I can send it in the Slack channel later, but there is a European publication where they describe the number of translators that they're trying to recruit, and they don't meet that number as it is before the derogation has been lifted. So obviously with more content to be translated, there'll be more translators needed to translate this content. So yeah, I think there will be a lack of translators to translate this, and I guess that's why it's so important to try and build machine translation systems that suit the translators, you know, to try and make their job easier any way that we can.
Yeah, because that's the idea of the European Union, right? To use an engine.
Yeah.
In case somebody doesn't know. So Miguel Meneses asks, have you noticed if post-editing experience influence post-editing time and post-editing keystrokes?
I can bring up post-editing time and post-editing keystrokes. It's not something that I tested for, but I guess we have the time and the keystrokes, so it is something that could be done, absolutely. I didn't take it into account for the paper, but it would be something quite easily done. I don't think I have, I don't have the table, the survey in, oh no, I do have the table as well. So participant 1 and 4 has the most experience. Yeah, I don't know, it's so varied. I think it is really hard to tell. With like all the results seem to vary massively. It's not something that we've tested, but they seem to be among the quicker. Just glancing, trying to do it on the fly right now.
Yeah, you can also pick up this question with more time in the translator track in a Slack with Miguel. So, yeah, this intersubject variability is what everyone that looks at post-editing efforts sees, right? So this is very much in line. Onia says, we are working on it in the DGTGA department. Goramahagot a Megan.
Oh,
so thank you to Megan. They are working on this. So
that's great to hear. No, I'm absolutely sure that they are.
So that's good. Josh, do you have any questions?
Well, I feel like I'm cheating as someone who's
involved. You are cheating. You are cheating. You're always cheating, Josh.
I might ask Megan to explain why you used a 6 gram model for Irish?
Yeah,
Yeah,
absolutely.
that's a good question.
So Irish is a verb subject object language, which differs to the subject verb object sentence structure of English. So for this reason, sentence structure is a challenge for English-Irish machine translation. So the reason we used the 6-gram was trying and capture a larger portion of the sentence and to hopefully aid the disparity in the sentence structure and improve the sentence structure.
Okay, yeah, challenging pair. So just one last question on my side. Before I hand back the baton to Joss for our second speaker. Did you only do a survey, or did you interview the translators after the fact, after the post-editing, to see, you know, what they thought about it all? I always find that interviewing people, you get so much information.
Yeah.
That's what I'm asking.
No, that's a good idea. I mean, all 4 participants were very willing to participate. So the survey, I don't know if I mentioned, was done after the fact as well. So after the post-editing task was done, but no, we didn't interview them. But that would be something to look at in the future. Absolutely, I think as well. I'm sure everyone thinks this about their own language, but Irish as a smaller language, as a minority language, I think that there's a really positive disposition if there's something that people feel that they can help for the language, that they are really open and really willing. So the participants that we had were fantastic, and I'm sure if we had asked them to do an interview, then that would have been possible. But no, it was just the survey, kind of an open-ended survey for when they had completed the task.
Yeah, we have seen the same with Catalan. People are more willing when you need your language to survive, right?
Yes, absolutely.
George is asking, are you actively encouraging technology providers to introduce productivity tracking features in commercial CAT tools?
Oh, I don't know.
That's a big question.
It is. I don't know if I'm qualified to answer that, really. I don't know. Yeah, is the real answer. I'm not sure. I think these are interesting results to have and to know afterwards, but productivity tracker in an industry capacity, I'm not too sure. I don't know.
Well, you use PET, which is maybe information for George. It's important that it's a research tool. It's not, yes. I mean, it's available, but it's not really for work. But some commercial tools like MemSource and MemoQ, they actually do track, and SDL Trados, they do track productivity, I believe.
Yeah, I believe so.
So thank you very much for the questions. Thank you especially to Megan and your whole team, some of them present here, for this wonderful paper. And Joss, I handed it back to you.
Thank you very much, Anna. And before Megan goes, I just would like to congratulate her on behalf of her colleagues and everyone here for passing her Viva within the last week. So good work, Dr. Dowling.
Oh, thank you. It's my first outing with the title, so very exciting.
Well, congratulations. And in response to Georg's question, there is a presentation a little bit later at 4:15 about a new interface that works similarly to PET, to track post-editing effort by Anthony Oliver, Sergio Alvarez, and Tony Badia. But up next, we want to report on a joint effort by the Faculty of Languages of the University of Cordoba and the Faculty of Translation and Interpreting in the University of Geneva. They were developing an open source web platform to teach MT to translation students. So this is a co-authored paper by Paula Estrella, Emiliano Cuenca, apologies for my pronunciation if it's incorrect, Laura Bruno, Jonathan Mutal, Sabrina Gerletti, Lisa Folkart, and Pierrette Bouillon. So I don't know who's going to present first.
Hello, everyone. I'm going to do the introduction, and then Emmy is going to move forward with the technical details.
Excellent. Thanks, Paula. So go on ahead.
Okay. So thanks, everyone, for joining this session. As Joss already said, this is a joint effort between our universities. Can you move to the next, Emmy? We have been working on this for a couple of years now. We had the first prototype that had two versions of this tool. It was a desktop-based and a web-based, both on Python, developed in Python. And this year we have released, or we are testing, a new version which has some more interesting features to be used in the classroom. And we have tested it in two pilots, one at the University of Geneva and one here in Córdoba, Argentina. So the motivation to create this platform was that oftentimes we wanted to teach students how to train an engine, or what happens if we have more data or less data, and what impact it has in the quality, for example. And sometimes the limitations are that we either need to use paid software or have a subscription to commercial systems to train them, and then oftentimes you also have to pay for the usage. So that was the first limitation, at least for our current situation here. And the other problem is that with the advent of neural empty engines, we all know that we really need to have a lot of computational power to train them. And the more data you add, or the newer models you want to test, the more computational power you need. And that, of course, for a translation student is sometimes prohibitive. We don't expect our students to have that at home. And the other thing is the limited user-friendly interfaces. So we started with these ideas maybe 3-4 years ago to develop some prototypes. And at this moment, we have this new version that we are going to present here. Emmy, the next one. So we've heard these arguments before, yesterday and the day before yesterday, and there are some motivations to work on this type of initiatives. Before this conference, we had we knew about these two initiatives, like Eamt, which is a portal where you can train your statistical systems and apply some standard automatic metrics. And we also had some knowledge about this new project called Multi-Train NMT, which we believe has the aim of creating resources for teaching neural MT to students. And previously this week, we have heard about two great initiatives. One is the Opus MT, and the other is MT WAC. I think we are all kind of in the same track of creating user-friendly platforms for our students. And I think we differentiate our issues, our projects in the sense that the previous one, Opus and MT WAC, seem to be more of a backend or servers to provide MT services. And our goal is to have a platform where we can integrate all the process, the entire workflow, where students can start with the corpus, train the engine, see how it performs, and then do some post-editing. So I think that's the main difference with all these projects and our project. So now I'm going to give the floor to Emiliano, who's our developer, and he's going to tell us all the technical details.
Hi, my name is Emiliano. Yes, I am a developer. I was working on this tool, and I want to explain some of the main features of this tool. MT3 integrates many useful open source tools into a single platform, trying to make it easier for users to interact with them. Many of these tools have no graphic user interface, so they need to be run using the command line. We know that using the command line can be very challenging and a source of frustration. in particular for those users with less technical skills. We believe that abstracting students from this, drawing the least possible attention over technical issues and letting them focus on what really matters, may improve their learning experience. MT3 features a client-server architecture with a web interface for users. This interface can be run in any computer, in any of the major browsers, so there's no need to install anything. This interface is supported on Google Chrome and Mozilla Firefox, and it is assumed that it will work in Microsoft Edge and Opera. On the server side, Docker is used to run a variety of tools, such as Moses and OpenMNT for model training. Docker allows to build modular systems, making the development easier and also the installation process. This separation in client and server has many benefits. Besides making easier the installation for the final user, it allows to run the more resource-consuming tasks on their server, even those that need specialized hardware like GPU for neural model training. MT3 has three main features. That is, users can train and share translation models, which can be either statistical or neural. It allows to translate using these models, and also it's possible to evaluate these translations. In the next slide, I'm going to dig deeper into these features using actual tool screenshots to illustrate them. This is a model creation screen. As we can see, it is possible to choose the type of the model. Statistical translation was the state-of-the-art technology until 2015, when neural machine translation models achieve a better performance in translation tasks. Statistical models are trained using Moses, while neural are trained using OpenMNT. These models are trained on the parallel corpus provided by the user. The corpus must be split into files, one with the source language and other in the target language. Files must be plain text, UTF-8 encoded. There must be one sentence per line, and the sentences must be aligned between files. That is, the nth sentence in the target file must be the translation of the nth sentence of the source. And we believe that was important to explain that currently MT3 does not support translation memories. Also, the language of each file must be specified, as each of the supported languages has particular rules for tokenizing. Once the model is created, it will be listed in this screen with the other users' models, and also with the shared models. That is the second panel below that. That is because MT3 has model sharing capabilities. That is, if end users need to use the same model, instead of training n models, MT3 will let you create just one model and share it. This feature can be very useful in a course, since the teacher can train one huge model and share it with students, saving a lot of computational resources and time also. Now, this is the model properties screen. Here we can get some general information about a particular model, like, for example, the corpus size, the pair of languages, creation date. Also, we can perform some actions over it. One of these actions is to browse the model files. These files are generated during training, and many of them has useful information that could help to a better understanding of the underlying technology. Users will be able to download the file or have a preview of it using the built-in file viewer. Here is an example of a file preview. In this particular case, we are previewing a GZ file. GZ files are compressed files. So if a student has to download this file to see its contents, he or she has to also decompress. So in this case, the file preview saves those steps. The final user can have the preview with only clicking, and all the decompression steps are made in the backend. Users can also make quick sentence translation to test a model. To give more insights about the mechanism of the translation, besides the final output, users will also get intermediary results, which currently are the output of the tokenizer and the output of the truecaser. The tokenizer is responsible for dividing a sentence into minimal lexical units called tokens. In practice, these tokens are words and punctuation signs. These tokens will be separated by spaces. We can see here, for example, that the tokenizer split prices, comma, into two tokens, the token prices and the token comma. The truecaser is responsible for lowercasing every token, except for those in which the capitalization has a semantic meaning, for example, names or nouns in German. In this example, as gold is capitalized only because it's the first word in the sentence, it has been lowercased. Both steps, tokenizing and truecasing, are very important for a proper model performance. It is possible to translate multiple sentences at once by putting them into a file. This file, as with the corpus, must be a plain text file with each sentence in one line. In comparison to individual sentence translations, file translations are saved internally so they can be accessed later. Translation output can be downloaded or previewed in place using the built-in file viewer. As we can see in this screenshot, the preview tool can be useful to compare source and target line by line. In this example, we can see, for example, that some words are not known by the model, so we decided to leave them untranslated. Finally, we can evaluate translation using standard metrics like BLEU, wear, and tear. As with models and translations, these evaluations are saved too, so they can be consulted later. In this example, we have a BLEU evaluation in which the same sentence was compared to itself. So that explains why the results are perfect. This was a toy example to see that the evaluation was actually working. Well, initially we wanted to create a reliable and extensible tool that could help teaching machine translation topics. We believe that we advanced a great deal in that direction, but there's still a lot of work to do. We can divide this work into new features and improvements. We have some exciting features we plan to add that are related to visualization. We have here embeddings visualizations. The embeddings generated by the neural model are vectors of many dimensions, but they can be reduced to 2 or 3D. So they can be plotted. By seeing these plot embeddings, we think that students can get some intuition about how the position in space has some sort of semantic meaning. Also, we plan to add a neural model layer visualization, particularly for the higher layers. And attention visualization. Attention also have some graphical features. It is related to alignment. So we think that it could be an interesting addition to the tool. Also, we plan to connect this tool with a post-editing tool that is under development. And in the side of improvements, we need to do a lot of improvements in the user experience, stability improvements, do a better error handling, a better error reporting, and add a logging system. Of course, we welcome every collaboration on development, testing, documenting. So if you want to collaborate with us, just contact us. Well, many thanks for your attention. And now, if you have any question, we will be pleased to answer or try to answer it.
Thank you very much, Emiliano. I do have one question to begin with, and that is you report on or you cite resources like Joey NMT, Mtraumatica, the interactive teaching tool, and mentioned Multi-Train MT project, and then from this week, Opus MT, MT Walk. Have you reached out to anyone who's been involved in any of these previous projects to do with a teaching tool such as this, or anyone who's worked on any of the previous user interfaces? So, you know, in the last presentation, Megan mentioned PET. There was a tool that I led development of in DCU, and it feels like a lot of work is being repeated. And by working together, we could, you know, manage to get a little bit further with some of this work.
Let me answer that one, because yes, we have been using, we also used at some point PET. The difference with these other tools is that if they are standalone, sometimes you need to move from one tool to the next and so on. So the idea here was to have everything in the same platform. And yes, of course, we are already having in mind to contact some of the other leaders of the other initiatives, just to see how maybe we can sort of, as you said, either reuse or put all the effort into one more standardized tool, or, you know, share this knowledge or experiences. Yes.
Yeah, I mean, it seems to me that even in the past, there's been lots of other interfaces that have appeared. I remember one for the Accept project, and I don't know if he's here, but Johan Roturier was looking to see if there was a way to repurpose that. And yeah, so lots of interfaces have been developed over time. The other thing I wanted to ask you about was evaluation. So a lot of us use the ASIA tool that was developed by the Polytechnic University of Catalonia. And have you tried to develop some sort of tool that works as a standalone evaluation sort of environment, or is it just as part of a process whereby you're training a system?
No, here we also know this tool, we have used it also, but the thing is now it seems to be either offline or maybe sometimes it's not working. Maybe I was okay. So but in our tool you can also run evaluations independently of the training of the models. It's not tied to the output of the training or anything else. That's something that we wanted to keep separate. For example, at the course here in Cordoba this year, our students used it only for evaluation because they were comparing different systems that were available online, let's say Google, DeepL, and so on. So they didn't want, or they weren't training any system, they just used it for evaluation.
Great stuff. If something like that would be really valuable, particularly to, you know, any university that's trying to teach translators about MT. It could be shared via the MT network or something else. There's a question from Veronica Keck. Do your translation students need to have IT skills and/or knowledge to learn how to train an MT engine?
Well, that's a good question. And that's one of the motivations we did with Laura, who's also in the audience. A couple of years ago, we did a workshop, for example, where we kind of forced them to train a Moses system. And it was really difficult because they mainly focus on the linguistic aspects, and they have other type of training here, not really related to programming or IT development. On the other hand, at the University of Geneva, the courses are really focused on this more technical part. So they do have the skills, and they are acquiring it during the course. So they are able to do it, but of course it's always nicer to do it through an interface, or you know, to kind of get away from the Linux terminal sometimes. This kind of abstracting layer that MT3 provides is what we were kind of looking for, something that hides all the command lines that we would run normally. So it's kind of a layer, a wrapper of these things, and that's our reality. Depending on the university, sometimes students do have those skills or acquire them. Here in Cordoba, they don't. They are not expected to get them. So that's why we think this is also kind of an interesting initiative for us here.
Thank you. I really appreciated how it made certain elements of the process transparent, like the true casing, for example. There's another question here from Leva Mackin from Ghent. Do students need to have access to GPU servers to train neural systems? But I presume this is all web-based, or is it?
Emmy, I don't know if you want to add to this, but that's also one of the advantages, that since it's web-based, everything's run on the server, and we have this similar to OpusMT, I think. We base the system on Docker, so there are some containers popping up and dying as the process is moving along, and everything's run on the server. So if an institution has to, let's say, make an investment on something for neural MT, they can do it, as in our case, for example, we would invest on one server, and that could be used by all the students in the course, because they don't have to have nothing special on their end. And then
was the
once
development
the
oh, sorry, go on. Yeah.
No. I was going to say that once the training is finished, they are supposed to get an email saying, well, your model is finished, and then you can go and see how it performs and move on to the other steps in the workflow.
And was the development of this funded internally, or how was it funded?
Well, that's another issue. We really did have small funding, and it was private funding from the University of Geneva, actually. So this is all happening because of that. And the rest was done through final projects of computer science students. So for example, Emmy, he just graduated, and this was his final project. So it's we don't have any specific funding for this. We have something going on at, it was supposed to be this year, but with COVID, we are stuck with the funding that we had. So we'll see how it works out.
Good work on pulling it together. I think that was one of the problems with ASIA, and it's often a problem with interfaces or with tools, is that the people who develop it move on. They're either on a short-term contract or are there as part of a final project, and it does make it a little bit difficult to maintain afterwards.
Exactly.
There's another question from Veronica Keck. How large should the corpus be to train the MT engine using MT3 in order to have good MT quality?
Well, do you want to take it, Emmy?
Yes. First, this system, I didn't say it, but the system is not focused on quality. The main feature of MT3 is to be able to train a model and see the internal side of it without any need to mess with the terminal. So unlike other tools, it is not focused on quality or acquiring some industrial quality. but also because the sharing of the resources between many students and teachers in the same server, we do not encourage to use many big corpuses, but one big corpus can be used. We think that with 100 sentences, you can get a decent model for translate, but again, it is not focused on industrial quality.
No, but of course there has to be, for pedagogical reasons, you know, there has to be an element where you're evaluating and adding data or removing data or trying different types of data and seeing what sort of a system you get based on that. So
adding to Emmy's reply, that's something that led us to share the models, that maybe students can create small models, but the teacher could create a really big one with much better quality, and then see the difference. What happens when I used 2,000 segments or 10,000 or 100,000? And then that's going back to the question, I think it is possible to use a big corpus, maybe with 100,000 strings. You will get something acceptable for some languages and domains. And maybe that's the model that the teacher could share with the students as a kind of good baseline. And then they can play around with the smaller things so that it trains quicker and comes back quicker to the student, because sometimes training in an empty engine can go beyond the timeline that you have in class. So maybe you start today, come back next class and see if it finished or something like that.
So here's one we baked earlier, right? So a final question from Gökhan Dogru from Barcelona. Are you planning to create a plugin or API for creating a connection between MT3 and CAT tools such as Omega T? And Gökhan thinks it'll be useful to be able to see translation results in a CAT environment for students.
Well, I don't think that's in the pipeline because, as I said before, we don't have a development team and a stable, let's say, team to work on this. But I completely agree that it would be great, and that's one of the features that I really liked about the MTWAC initiative, because it does handle tags, so you could see what happens if you train with and without tags, and how translation performs, and then you could plug it to your CAT. And I think that particular initiative would be quite interesting for advanced students, for example, where they would be focusing more on the post-editing side, on the linguistic quality, the value they would add to the machine translation, and not so much for the students in, let's say, third year, where they would be just learning the basics, what's MT, what's post-editing, how it works, and so on. But that would be a great feature. We don't think are going to do it, and that's why, to be honest, we were talking, maybe we have to connect with other people who already have developed this and see how our efforts could either be combined or shared. I don't know.
Maybe you have sponsors in the audience. We should
Hopefully,
ask the sponsors that are listening. It's very commendable that you have done all this in my home country, in Argentina. I think it's difficult to pull this without universities that are very much under-resourced, I imagine. You know, even if in Spain they are, I cannot even imagine in Argentina.
Yes, if I may, I would like to add on that. It has a lot of merit because it's
a lot of merit.
Really volunteering work. Students like Emiliano and Johnny, who's also part of he's now doing his PhD, and some previous students. So it's been all kind of volunteer work, and the only, let's say, payment has been the degree, which is not less, but it's hard to keep these initiatives going without funding. And as you probably know, students, we can't compete with industry. Now Emiliano is a data scientist at a big company. So how could I engage him to keep working on this, you know?
Of course, of course.
So,
but anyway, I think what I saw is great that the students have the opportunity to see all this data, you know, and like Joss said, it would be good to have a big team, transnational team, to work on this type of tools for education.
Yeah, absolutely. Well done on pulling it together.
Yeah. Congratulations, Argentina, Cordoba, Argentina.
thank you.
And there's over 100 people here, so I'm sure they
Somebody give us the money, give them the money.
there's
Give
some
our
feedback
students
here
the
from-
money. They do a great job. You know,
Yeah,
we
yes.
have a lot of valuable people. We just can't keep them here at the university. They need to fly away. I mean,
And Mikel
that's how it
Forcada
works.
does mention here that anyone living in Europe can become an EAMT member and apply for a grant from EAMT to fund small projects.
Good point.
AAMT do the same for the Americas as well. But we better leave it there. Thank you very much, and to all of your co-authors, and to Emiliano and to Paola for presenting your work. Thank you very much indeed. I'll pass
Thanks
over
a lot to you. Have a nice day.
Thanks.
Yeah. Thank you. Very interesting project, as Pascaline Mertens says here. So I think
Thank
people
you.
found it very interesting. So now we are going to have a series of short poster presentations, one after the other. So unlike the previous days, you don't have to choose. You can stay here, I think, I hope. If we disappear, then. So our first poster presenter, so it's going to be 10 minutes and then 5 minutes for questions. So they are going to be a bit faster. So our first presenter is Maja Popovic, who is going to talk about different translations or comparing different translations, considering expertise and native language. By the way, if there's anything pending, remember to go back to Slack and discuss with the presenters more things. Maya, whenever you're ready.
Yes, so I'm right, and then just to share the screen. So do you see my screen?
Yeah, we see it. We see it, Maya.
Okay, great. So this is a work about differences between human translations, because there is a lot of work about that translations are different than originals. I mean, human translations, and then even more that machine translations are different than humans, and so on and so on. But what about different human translators, like text translated by different translators? So we tried to dig up a little bit in this and to see where there are differences between human translations according to expertise and also according to native language and translation direction. So about data sets, so this is really a bottleneck here, but we were able, thanks to many people, some of them are, I guess, in the conference, so thank you again. So their names are in the paper. So we managed to figure out that in WMT sets, there are some different human translations. And this is a very good starting point, but none of these data sets is really perfect because there are always some problems. For example, either it's too small, either source language was already a translation, either there was not. So the main problem is that it's never same source language for each translator. So human translations are not parallel, but only comparable. But still, we were able to see some things. So the text features are shallow text features as a first experiment in this direction. So it's basically sentence length, average word length, then lexical variety, which is like number of different words divided by total number of words. And also we try to extract kind of morphosyntactic variety, like number of distinct part-of-speech tags, like rich part-of-speech tags, including morphological information, divided by total number of words. And also lexical density, like the amount of content words in the whole number of words. So what happened there? So like, it's also important that we didn't observe the absolute value, like absolute lexical variety of this text, but we observed relative difference between source and target. So why? Because first, we have very different language pairs. So we wanted to reduce the impact of really language characteristics in their relations. And then second, as I said, this is only comparable corpora, not parallel. So we also wanted to diminish this impact. So short about the test. So like for the expertise, we had English, Croatian, and German, French datasets. The cohorts were professional translators, crowd, student, and also specialists, which is kind of the person who knows what he's doing. He has a professional experience, but it's not that they're living from professional translations. I mean, I might be considered one of those. So what happened there? So for example, lexical features. So we can see that sentence length and lexical variety clearly vary. For the rest is not so really, like lexical data, not really, word length, not really, and part of speech variety, yeah, not sure. So it's for English, Croatian. And then when we look into the other set, German, French, then again, sentence length and lexical variety is, yeah, varying. So this is kind of interesting. Then for English, Croatian, we were a little bit lucky that we had some parallel human translations, not all of them. So we wanted to do some automatic evaluations with different human translations. And then, I mean, this is nothing new, but this is also nice to see that each of those translations actually provided different automatic scores. And then even if you want to compare two systems, then you might come to some different conclusions. Like, for example, with this one of the crowd translations, sometimes it's Bing better than Google, and then with some other one, it's Google is better than Bing. It also depends on automatic metrics. So yeah, there are some things going on there. Then about native language. So we had again German, French, and we had also some English, Finnish translations. So it was all professional translators. So that's maybe also important. And then what was happening there? So first we had one translator, one same translator, but translating in two directions. So we can observe that actually all those shallow features were kind of different, except of part of speech variety, morphosyntactic variety. And it's still hard to conclude anything, but it's obvious that there were variations. And then about the other thing was when we had one translation direction, but then two translators with different native languages. And we can also again see that all of them are different. And then what is maybe also interesting to mention is that, that there is also a lot of variations with word length. So that's kind of looks that the native speakers generate longer words when they translate into the native language than when they translate in the other one. So the other features are still not really clear what's going on, so deeper analysis would be interesting, but at least, I mean, there are certain tendencies. So this is a short presentation, so I promise to be short. So our results indicate that regarding text features, so sentence length and lexical variety seem to be affected by all factors, like by expertise and also native language. And then word length varies depending on native language, as I mentioned already. The other two features, this is not clear what's going on, whether anything is going or not. So more analysis should be carried out there. And then regarding empty evaluations. So I recommend that it's important to specify which kind of human translations are used in evaluation, like whether they were students, whether they were native speakers, whether maybe years of expertise, maybe. And then especially, which we were hearing about a lot these days, like comparing human machine translation quality. I mean, it's really worth to say, okay, our system is better than professional, or our system is better than student, or our system is better than native speaker, or stuff like that. And there are a lot of potential for future works if some fully appropriate data sets can be provided, which should be parallel instead of comparable human translations, like all of them same source text. So we would also like to investigate, of course, more languages and language pairs in more domains. And then if we manage to get some data sets someday, then the plan is maybe to do some more in-depth linguistic analysis of differences and also more analysis of effects on automatic or human anti-evaluation. So I hope I was not too long.
No, that was perfect, Maya. While we wait, if somebody wants to open the question board, maybe I would like, I don't know if everyone is aware of the source of your comparisons. So where did you take all this human translation? I think maybe the audience will benefit from knowing who are these people. You know, where did I take the data from?
Okay, so the people are, I mean, different people. So there are, as I said, so professional translators, and then translation students. And it was also one data set with crowd. So, I mean, who was in the crowd? No idea.
But is this something that you did in an experiment, or this is data taken from some data banks?
Data already existing from WMT test sets. So
exactly. This was where I wanted to get.
I was just, I mean, getting such data is difficult.
Yeah. So this data is very mixed. You don't really know. So when they compare with human, we don't really know what they mean by human, correct?
Okay, yeah, yes, actually, yes. I mean, for example, the newest Czech paper is very good about that because they really say it's about the professional translators. There are some translation shifts which human do and the machine system doesn't, and so on and so on. But in general, like, okay, it's better than human. Yeah, which human?
Yeah. Exactly. I think this is the nice thing about the paper. Antonio Toral is asking, could this lead to a classifier that, given the source text and a human translation thereof, predicts, for example, whether the translator is a student, professional, native, non-native, etc.?
Well, yes, I mean, it could lead to classifier, definitely. But then again, if more data can be gathered, because with just 1,000 sentences or even 200 sentences right now, it would be difficult.
Or maybe also whoever gathers the data for the WMT,
yeah, of course.
They need to annotate more characteristics about the origin of the data, right?
Yeah, I mean, it doesn't have to be WMT. I mean, whoever
anybody
gather these data, it will be nice, but it's important that they're parallel. For example, students, I mean, okay, so let's forget about native language because it would be really difficult. Right now, I don't have clear ideas still, but for expertise, it could be really important that the same source sentence is translated both by students and by professionals. So then we could understand better what's going on.
What's going on with even human parity. So thank you very much, Maya. Very interesting comparison. Just I hand it over to you.
Thanks, Anna. It's really interesting how, and it's probably a good sign of the increasing crossover between the MT community and people from translation studies, that we're seeing more and more citations of translation studies work in some of these papers from Maya and from Antonio, and it's, I think, really healthy. So the next presentation is by Antoni Oliver, Sergi Alvarez, Toni Badia from the University Oberta de Catalunya, and Pompeo Fabra, about it's the one I mentioned earlier, Posedion, a post-editing assessment or assessing tool in Python. So Antoni, I'll pass over to you.
Yes, thank you. Can you hear me? So I will share the screen and also the presentation here. We have here the presentation, it's okay. And then full screen mode. So yes, I will present this tool for post-editing assessment. So this is a standalone tool, but simple tool with the aim of collect central level information during a post-edition process, where when the post-editor is post-editing some text, it can be used for post-editing, but you can also collect this information for translation. If you don't put any machine translation proposal, then the translator can translate the sentence, and it collects all these kind of keystrokes, time. Also, if the application loses the focus, and also on. And then with all this data, we can calculate several scores. And this tool can also offer a visual representation of the data. So the idea is that there is several other tools for post-edition annotation, and some of them are plugins for some CAD tools, and some of them are standalone tools. So this post-edition tool is inspired in PET, and maybe you know this tool also. But we have to use PET for some experiments, and we find some problems with the Java versions, and some problems for creating the projects, and somehow a little bit difficult. So we decided to create a similar tool, but with simplicity in mind. So it's a very easy tool to configure, to use, and to take the data, prepare the projects, and so on. So this tool is developed in Python version 3, but we can also create a Windows executable from this Python code. And the idea is very easy to use and to configure. And all that you need for when you send, or when you assign a post-edition project to a post editor, the only thing you need is to send a folder that contains everything. So it contains the program itself, and it also contains all the needed files. So the post editor receives this folder, decompresses the folder, and then run the program, and he doesn't need to configure anything, to select any file. So he or she will find the text and the text, the translation, and he will post edit this. This is to avoid errors when selecting the wrong file, or when so everything is contained in one folder, and the post editor runs the program, begins to post edit, and the idea is to avoid errors and problems. So a project folder contains the post-edition program in Python, or the executable for Windows, as you like. A very simple tab delimited text files with the project, and the project is several fields separated by the tabulator. So you have the count of the segments, also an ID of the segment, and then you have the source segment. And if you want to create a post-edition project, you have also the machine translated segment to post-edit. But if you want to measure some the keystrokes and time to translate, then you don't provide any machine translation segment. So you will provide make an experiment about translation. And one configuration file that indicates which is the file to open, and where to put the results, and so on. And then when the post-edition starts, a new field is added to this project file with the post-edited segment, or the translated segment. This is a translation project, the translated segment. And it will be also created an actions files. I will show this is a file with one line, in each line, one action or one event. So a keystroke, a change of focus, or maybe a change of segment, and going back, going down. Everything is registered with time and keys. So well, I will show you later. And the interface is very simple. The post editor is presented with this interface with the source segment, the machine translation segment. If you want, you can activate here a chronometer to see the time what is going on. But if you want, you can hide this chronometer, and then the post editor makes all the post edition here. He can accept the segment going back, going down, but in a very simple environment. So when the post edition project is finished, you can stop a job and start another time. Then you use the same files, and the time is kept there, and so you can start and restart the projects and so on. So the important thing here is we create an action files with all the details about everything. The project is started at the time, then she changed the segment, then he presses the key A, the key C, then he presses the mouse, and then the change, and everything is stored in a very simple text file that will be analyzed after the finishing the project with another program. The important thing here is if we are keeping all the keys that are pressing the post editor, but only if the application is in the focus. If he changes the focus to an email and so on, anything will be registered there because it will make some problems for the analysis. Then we provide another simple program to analyze this data. Then you open a project there where you have everything, the project, also these action files and everything. And then you press the analyze button, and then you have several measures here. So you have the time, the total time, all the keys, the total keys, and also ActBleo, human edition, and Acter. And then we provide two measures, two versions of each measure. One is we call prune. That's simply we don't take into account any segment that has either more than the mean of the time normalized by characters, plus 2 times the standard deviation, and also for keys, for keystrokes. So if some post editor maybe has stopped the task, but he didn't stop the program, and this segment takes too long to be post edited, then we can keep it out. So another interesting thing is that you can get all the detailed measures for each segment. So you can, this is also a text delimited, a tab delimited text file. So you can also use any external program or any spreadsheet or anything to make further calculations. We also provide a couple of scripts to create some graphs of distributions of actors and ActBleos and so on. But there are simply the graphical representation of the results. And this program is released on a free license. Here you can find the old repository in SourceForge. We have changed it to GitHub. But from in this repository, you also get the link to the new one. So we are using this for research, both in industry and also for teaching post edition at our universities. So we're making some research on post edition, and also for training translators, and they make some experiments, and then they understand how the quality of the machine translation system can affect to these measures and so on. As future work, we are, well, maybe we will want to make some capabilities of the tool to make some annotations of the errors, or some kind of annotation in an NQM framework. But for the moment, we only have this editor and the program to analyze the data. So in general, it's a very useful tool. It's like PET, but maybe it's easier to configure, also easier to get all the data, because we are not using XML files that is more difficult to prepare and so on, and everything is in a tabulated text file, so you can prepare the project very easily. And also, if you don't want to use this program for calculating these measures, or you want to calculate different measures, you can take all the data of each segment and then calculate outside in a script or in a spreadsheet and so on. So this is my presentation for this tool. And if you have any question, you can contact any of us in this email address. So I think I'm in time also. So thank you very much for your attention.
Thank you very much, Anthony. If anyone has any questions, please feel free to pop them into the Q&A window. And I have a couple. First of all, what are your thoughts about the presentation of the user interface? So was it that you were copying what's done within PET because it's vertically aligned? There's no context for for showing segment by segment. Was that something that you considered, or is there a way of being able to see sentential context or intersentential context within this tool, Anthony?
Yeah, no, we didn't consider this because it will make
paragraphs.
Yes, I know. Well, you of course you can prepare projects for showing one paragraph if you want, because this is a text file, so you can put a paragraph in one field, so you will poster it by paragraphs, but or by segment as you like. But we are not providing any context because it will make the tool more difficult to use, well, or for the user to understand what is everything. So of course it will be better to have the context, but you can always go down forward or backwards, so to see the previous segment. But the important thing is, if you would prefer to poster it by paragraphs, it's also possible, but we don't show the previous paragraphs or the next one, but it would be not very difficult to implement. But for the moment, we don't consider the implementation.
Mm-hmm. And do you have any plans to increase the summarized data that you can export at the end, perhaps including deletions or shifts or pauses? You mentioned that you wanted to use it for looking at post-editing effort, and if you're thinking of pauses as an indicator of post-editing effort, would that be something you would consider including or adding in as a
you mean
category?
in the detailed results in this
yes,
file?
in the sort of summary file.
Yes, it would. I can implement this. We didn't think about that, but of course, maybe it's better to provide more information, or the idea is to in this analyzer, the analyzer takes the action files and gets all the results. So that in the configuration file, you can we plan to put that you can tell, I want to have the trial results with this data. So I want the deletions or the how many keys, but at the moment they provide this time and keys, but it's straightforward to implement. So I will consider to put more data on there. Yes.
There's a question, I think, from Clara Ginovart, who I'm sure you're familiar with.
Yes.
Hi, Anthony. Thank you very much. I'm loving Eamt so far. I've not tried Posedion, but in the industry, we'd like to have it run in the background of CAT tools, such as Studio and Qualitivity.
Yeah.
However, the keystrokes in some measures cannot be easily converted to graphics in Qualitivity. Do you plan to merge or combine these features of Posedion with Post-Edit Compare or Qualitivity in the future?
Well, maybe in the future, if there are teams using the tool and they provide feedback and say that it will be useful to do this and that, maybe we will consider to put, because it's very simple Python code, so anyone can add this, but I will be happy to put in the code. So we have designed the tool for our experiments. We know that sometimes it's better to use the same tool as the translation usually use, but you don't never know if they use Translation Studio, maybe this another tool. So the thing is, it's better a simple tool with a simple way to use this, or to put this as a plugin. Well, this always these questions for our experiment with the students and with professional translators, we decided to create this simple tool.
No, and I think it's really useful, and it's excellent that you shared it with the community as well. So thank you very much for presenting it to us, and I'll pass you across to Anna.
Thank you, Anthony.
Thank you.
I might ping you on this tool later on in the translator track there in Slack. I have some questions, but without delay, Sergi Alvarez, Antonio Olive, Antonio Badia, but I guess Sergi is going to be the presenter, is going to show us a quantitative analysis of different post-editing efforts in two NMT systems, in the English-Spanish combination and with medical text. Have you used post-editing as well, Sergi, for your...
Yes.
So great, because then we will see it in action. Thank you.
It was the first testing of the
you were the guinea pig.
In fact, we developed it as part of my PhD because we didn't have a tool that really was easy to use and that we could just use for the experiments in an easy way, taking into account that we used for some of them people who were at homes or translators, professional translators who weren't very techy, so they just didn't find easy to use certain tools. Okay, so now I'm going to talk about the other paper we're presenting. That's a quantitative analysis of post-editing effort indicators. Now, the idea is, well, this is a bit of what I'm going to talk about. The idea is that currently post-editing is being used more and more, and there is a real hype in all the industry. So we are trying to understand what's really going on. And it seems that neural-machine translation is really what everything is going to. So research has shown that many of the results are better, and it reduces word errors and it increases fluency. So we wanted to see how two NMT systems worked instead of comparing SMT with NMT. But we also wanted to check on the post-editing effort indicators, so the relationship that there was between them. Because usually automatic scores give a good idea of what's happening, but there are many problems with the correlation of these automatic scores with post-editing effort. And so what do we understand when we talk about post-editing effort? In our case, we only talk about the temporal and technical, so the time that they take to post-edit the segments, and also the keystrokes that are used to post-edit. For our experiments, we used the English-Spanish combination with medical domain. And we analyzed these correlations and the measures, direct and indirect measures that we take from the post-edited document. So not only seeing what has happened while the translators were post-editing, but also analyze the tools that Postedion produces in a quite easy way to see if they really correlated with what had happened or not. Now, regarding the MT systems, one of the important things that we wanted to take into account is that the corpora used was the same. So we trained two systems with...
Sorry, Sergi,
yes.
Are you showing more slides? Because we can only see one, or is it only me?
Yes, oh my God.
It's not moving for us.
Is this...
Was it moving for you, Josh? No.
Only the... It wasn't moving for me either, just on the main title slide.
Okay, so we only saw the title page. Sorry, I didn't tell you before because I thought it was an introduction.
I mean, I just don't know what's happened. Let's read again. Can you see that now my screen?
Yeah, we see this. Can you?
And now it's moving?
Okay, now it's moving.
Okay, I won't take it into full picture. Instead, it moves wrongly again. Okay, so that was the idea what I've just said now. The automatic scores give a good idea, but it's not the post-editing effort. There's not a clear correlation with the post-editing effort indicators. Now, regarding the NT systems, we had developed taking corpora already existing, which was publicly available, and also with other corpora from websites and glossaries. And this corpora was used to train the two systems. So it was a fair competition between the two. We used Marian to train both, sorry. And the idea was, first of all, to see how they both worked using a Moses trained model with the same corpora and also Google Translate to see if the systems were okay or there were problems. As has happened in some of the research, Moses was the one which obtained the better blue scores. And other research has shown that perhaps NMT is underestimated sometimes. Now, we conducted a manual analysis following Graham, so a direct assessment of some of the segments with two annotators, and it really was clear that the NMT systems were better, they were more fluent, and the translation given, although it needed post-editing, was better. Now, with this in mind, we took this the two empty outputs from the two systems and translated 3 texts. So the idea was we didn't have too many translators to translate the text, but one of the things that we did was we did this with a grant from the Pompeu Fabra, and with the limited amount of money we had, one of the ideas was to translate more than 300, 400 words so that we could have just more information, more data to assess what was happening. But that meant that we could only use 4 translators to post-edited the segment-to-segment output and the other 2 the transformer NMT output. And obviously they used Postedion, which they found very easy to use. All the comments were nice. The one comment that wasn't so favorable was regarding context, but Anthony has already explained that, so you can move forward and you can move backward, but you don't have the whole text. Now, regarding the effort indicators, the ones that are calculated with Postedion that we took more or less and modified. So the post-editing time in seconds, normalized, then the actor value, ACT value, editing distance, and the keystrokes, also normalized by the number of tokens. We have here the information about the translator, and as you can see on the other table with the bold thing, in the mean from all, clearly the transformer model in all measures was better. So we really can conclude the transformer model the system worked better for post-editing, so the results were better. Now, one of the things that it's always a problem or something that happens that really made us curious and we are very interested in is the differences between the translators that we also analyze when we see all the difference that there are. There's always all the difference, but one of the things that we studied, taking into account that difference, is that what happens between the different indicators. So was there a correlation between the actor, ACT bleu, the keystrokes, taking into account that every one of the translators took some different times the rave and press more strokes or less keys. And we saw that taking time as the main measurement, because it's what really is used usually in the industry. There was not a clear correlation with all these measures, with all the actor, but there was a clear correlation with the number of keystrokes. So the more keystrokes, the more time, the less keystroke, the less time. One last thing that we take a look at was what had happened with the best 50 segments and the 50 best segments and the 50 worst segments. And that showed that the segments that were better, so the ones that were, some of them not even touched, so they remained the same, were really more or less, there was a clear correlation or a better correlation with all the, more or less with all the measurements, but not so much with worse segments. So as a conclusion, there is a certain tendency between the correlations, but there's not a clear way of really indicating, oh, we take into account this measurement and this is going to be the one that clearly gives us the information. So although, as I repeat, temporal effort and keystrokes are related. So we believe that taking this into account, plus the fact that there is a clear variability among translators, which is a thing that we also are very interested in and want to really research more. We think that an approach that takes into account some of the elements that take part in the process would be a really more safe approach in order to produce post editors who are really satisfied with the job they do and can post edit an empty output that's of quality enough, of a good quality, and does not produce the problems that we are sometimes hear translators telling us that they have to redo and retranslate things that in theory they only have to post edit. So our future research is going more in the line of a more multi-dimensional approach, so taking into account even source, so the empty output, and the analysis of what has happened after a post edition, a test post edition or a pilot post edition with some translators. Thank you very much.
Gracias, Sergi. So we have some questions here. The first one from Clara Ginovart. Sounded very weird. So, hi, Sergi. Thank you very much for the presentation and congratulations for this work. I was wondering if the final edits have been evaluated to spot over or under and pseudo editing issues. Thank you.
Yeah, not yet. This is, well, as I've explained, I think before, this is part of my PhD and the things we are analyzing. This is one of the steps from this multidimensional approach that I think that needs to be taken into account, which is a step that should be done after the post-editing has been done. So what are the errors on what has been marked? Obviously, this cannot be done in a large scale. But yes, if we are working on a specific client, for example, or a specific empty system in a certain domain, it could be interesting to see what exactly do they change or not, taking into account all these translators were professional translators with experience post-editing. So they weren't students who perhaps over post-edited. They were just people used to post-editing as a way of life and which did that in a professional basis, and they all were medical professional translators, so they really were doing that in a daily basis, and even so, there was a great variability.
Yeah, that's interesting, although common. Miquel Fulcada says, good correlation of time and keystrokes means there is roughly a constant typing rate. But how about mouse moves? Were they taken into account? Do I repeat?
Yes.
So
I have it here.
Yeah.
No, they weren't taken into account. No, because they were, as Antoni said, they were registered, but we didn't analyze them. No.
Then Evelyn Young Garland says, thanks for the presentation. Did temporal effort include research time?
Yes, that's a good question. I think that post-editing time should include research time. So if not, there's some sort of strange data that we cannot use. So a real world scenario in a professional translation world means that they could just research all the things that they needed. That meant that they could just click the pause and search whatever they needed, take glossaries or search the internet, and then continue. If they were doing the search, they didn't have to press the pause button because that was part of the post-editing process. But yes, they should press the pause, and I think everyone understood. We gave the tool beforehand so they could practice with the tool, and we also give the instructions. They could stop it or pause it if they wanted to go to the toilet or to whatever, or stop the post-editing, but the research time was included.
So I'm going to, we have 2 more questions, so I want you to have the time to answer. Well, Lina Mark has more of a comment that says, when we once looked at this, I think human evaluation still correlated most strongly with productivity gains. Okay. That was segment level, adequacy, and fluency Likert scale at the time. I don't think I understand the question, but maybe you do.
No, I think human evaluation still correlated more strongly with productivity gains.
So more productivity gain, higher human evaluation, obviously.
Okay.
But you didn't have the, so I guess the blue scores. Did you do human evaluation in your project? Oh.
No. It was in this part. So as I've explained before, the idea was we've looked at many things related to this post-editing quality, and on previous research we just found that there was a correlation. But the problem is that even as someone has said before, I think even when post-editors assess, or human professional translators assess the empty output, it does not always, and Josh had that in some research that he did some time ago, does not correlate. So even if you take post-editors to evaluate the results of the empty output, it does not correlate directly with post-editing effort. So they think that the post-editing, the empty output is okay, but then the post-editing effort sometimes is higher or lower than they just think that's going to be.
Well, I think this is highly variable. But to go to the last question before we move on, and this is interesting, which type of feedback about the tool, because we are thinking of using this, did you receive from the translators?
We asked about the tool and what they thought about it, and in general they found it very easy to use, which was our main goal. So they could open the tool. There were no complaints, so that was wonderful, because when we use PET, there were many complaints because they were not used to using different tools. Even they used SDL, but or some similar tool, but not any other tool. The only problem, as I think I mentioned before, was that they thought that perhaps they would like to have the context all in the same screen. So being able to access the context, and also having other tools related or more usual in post-editing environments, such as spell checkers, for example. But the problem is that the more other tools we include, the less able we are to control what they are doing. So in this just of sort complicated measure, we decided not to include any spell checker.
Thank you very much, Sergi. If you have more questions, you can go to the translators track in Slack. Josh, over to you. This is like
Thank you very much, Sergi. I thought those 2 papers dovetailed very well. So up next, we have Felix de Carmo, formerly of DCU with us in Dublin, now in University of Surrey. And he's going to tell us about the results of a workshop in which 50 translators tested some experimental translation interfaces as part of a project studying the details of editing work. So Felix, it's over to you.
Hello, thank you, Joss. You've just released me from presenting the title, so I'll move on. Yeah, so the motivation and the scientific context for this project are related to previous research on interactive translation. And the main question here is, how can we feed machine translation content to translators through their translation tools? And there are 2 main models, which we know already. The first one is interactive machine translation, which models translation as a linear writing process from beginning to end. Translators see the suggestions for the words they are typing, and there is a cognitive interference here. The suggestions that they see change over time, and so this creates a few problems. And the other model of work is post-editing. In this case, we consider that the work is not linear. You press a word here, another word there to edit them. The question is whether we have interactive models that really support this type of work. Most of the work that we see on post-editing is based on word replacements, deleting a word and replacing it by another one. But edit distances like TER, translation edit rate, measure actually 4 different actions: deletions, insertions, replacements, and movements of words. So the motivations for this work was, one of the main ones was do translators really post-edit using these 4 actions? And if they do, can we develop interactive post-editing systems to support these 4 actions? Another important theoretical concept at the beginning of this project was that we may need an editing threshold that separates segments that only require this scattered editing from segments that require full retranslation. For this experiment, we set this threshold at 25%, which is the inversion of the 75 fuzzy match band that usually is used in the industry. So we ran a workshop, and the main purpose was to collect data on these actions. Not only the words that were deleted, inserted, replaced, and moved, but also the positions that in which these edits were made. And for that, we also needed an interface. That seems to be a common theme in this panel. And the reason being that edit distances do not record the process. They are just estimates of the process through the product. And also keyloggers do not have such a fine-grained level of interpretability of units and positions. I talked to Chris Holcomb from IndisU at the time, and he developed an experiment extension of a research tool that he had created, HandyCat. He didn't have lots of time to develop it, and at the end, what was planned as a pilot test became the actual workshop. So these are the 2 work modes from HandyCat. On the left, the one that we called autocomplete. It completes the words that translators type. On the left, on the right, the post-editor mode. So here, translators selected a word or a space, and then they selected whether they wanted to delete that word, insert a word in that space, or move or replace the words. We had 50 professional translators in this workshop. They edited 4 texts from English into Portuguese, which had been pre-translated with MateCat. The texts were very different, from instructions, questionnaire, a catalog of office supplies, a paralegal text, and we ran 4 different sessions with 3 texts. The first one was used for familiarization. In each one of these sessions, translators used different text, and they alternated between autocomplete mode and post-editor mode, and in different times. So all of them edited the 3 texts, but not in the same mode and not in the same sequence. They also, all of them did 2 sessions on each mode and 2 sessions with the same text on different modes. We didn't have any speed requirements, only time limits. In total, we collected 26 hours of work and more than 8,000 edited segments. And we collected that data through activity logs of HandyCat and also questionnaires that the translators filled in. And to collect edit scores, we used the previous version of Qualitivity, which is called Post-Edit Compare. In the project, we had several independent variables, which were texts, segments, users, modes, and actions, and questions related to them in terms of identifying the influence that these factors could have on the results that we were observing. And the dependent variables were first the edit scores, the number of edits per segment, and also the TER scores, which is the normalization by the length, and also speed. So moving on to results, I could present lots of detail on these results, but this is just a selection of some of the most important ones. So in terms of text, the average TER scores per text in the total of the text is 25%. So at the threshold that we had identified. And this is an average score that we see in other places. But if we look at the text with a bit more detail, we can see that the highest average score and the lowest average score were done in the autocomplete mode. So apparently the post-editor mode concentrates the results in a shorter range. And we could see this all across the analysis that we did. In autocomplete mode, there was a bigger dispersion of data. In terms of users, one of the most interesting analyses was ranking them by speed and by number of edits. So we rank them by TER average scores in the vertical line, and then we rank them in the horizontal line by speed. And when we separated them in halves, we could see very clear 4 quadrants there. So in the top left corner, we have 12 translators that are the fastest and the ones that do more edits. And in the bottom right corner, the ones that are slowest and do less edits. This seems to be very clear, but I wanted to highlight that this is only part of the picture. We are just measuring numbers of edits and speed. It's nothing to do with, for example, trying to use this to identify the best post-editors. Handicapped by presenting this possibility for translators to choose the action, recorded this as events. So this is the number of times the total translators chose to delete a word or to replace it. And we can see that there is the action that was most frequently selected was replace, then it was deletion, then insertion, and finally movement. The TER scores, the estimates of TER scores are very different. So for each event, for example, for deletions, we can see that TER identifies more deletions and it also identifies replacements. And this disconnection between what translators were actually doing and what TER estimates is an evidence of how far it is from the actual actions that translators do. This was analyzed again in another work that I did. At the end, we got everything together. We coded the answers from questionnaires, and we created a matrix with 27 data points per user. And we looked for, using different tools, the strongest correlations in terms of these factors and the results. And one of the best tools to present the results for this was a decision tree, and we could see that text is the element that is most closely correlated to the number of edits that translators do. The same type of tool, the same type of analysis for speed showed that the mode of work was the strongest factor associated with speed, followed by experience in predictive writing. Okay. One final set of results from the questionnaires. We could see that translators thought that the autocomplete mode in blue there is a faster method to work with, an easier tool to work with, better for translation, especially if they are working on longer sequences, whereas the post-editor mode was considered more intrusive, but that still had some advantages, especially in shorter edit bursts, and also because it allowed translators to plan their work. So conclusions, it was interesting to see the average of 25% editing change across texts, users, and work modes. It was interesting to see as well this correlation between numbers of edits and text and speed and work mode. The post-editor mode had some advantages in terms of consistency of edits, reduced number of re-edits, and so on. And it was also interesting to see the ranking of users by speed and edits. In terms of the actions, The frequency is similar to what we see elsewhere. First replace, then delete, then insert and movement, and insert and replace implied typing, so they can be used, supported by autocomplete, not so much deletion and movement. And finally, this summarizes some of the research interests of this work. Intrusiveness can be used to filter strategic decisions. Edit distances are not descriptions of processes, but of processes, but of products. And all of this concurs to giving more visibility to a complex system, which is not so mechanical as one might think. And thank you for your attention.
Thank you very much, Felix. Please, if anyone has any questions, pop them into the Q&A box right now. I have a couple for you. So first of all, your recruitment was pretty successful. 50 participants is fairly heroic. How did you attract them? Were you paying them? Did you offer to train them?
No, so I did this in Portugal, and usually we don't have money for research. We pay our own research, and that's it. No, the approach was to suggest to them a workshop in which we would discuss new ways of doing post editing, and there was a lot of interest on that. So I tried to give them useful information for them and exchange that for their participation in the study. And translators are very nice people. Lots of them came, and it was a very dynamic workshop. It was really interesting. Yeah.
And what's your, you have a unique perspective as someone who's a researcher, but is also a business owner. And based on your experience along with this work, what's your impression of what people interacting with most machine translation prefer? What sort of mode that they prefer, or what works best for any particular scenario or circumstance or type of text?
Yeah, it's difficult to say that, right? Because professional translators use very different tools in the same day. They jump from one tool to the other according to the different projects and requirements of clients. I think that at this moment, people are really looking for more support. We are being fed with machine translation without any filters and correcting the same mistake over and over again. So I think it is a good time to test interactivity, because most people really are looking for ways of interacting with machines that are beneficial for them as users. And most of the discussions are about translators helping the machine translation, not so much in the other way around.
I've been involved in Translating Europe Forum over the last couple of days, as well as being on Eamt, shock and horror. And there's a lot of discussion there about platforms and a multiplicity of platforms, and a worry that we might be going backwards in terms of usability by having all these many different interfaces instead of having years of development behind the existing ones. It's a pertinent question, and certainly one that crops up to do with the test beds that we use. So just this afternoon, we've heard about experiments using PET, Posedion, and now one using HandyCat. So it does put into question the comparability of results from our different pieces of research.
Yes, absolutely. And we also always hear this comment that if you want more details, the tool has to be more complex. So there is a debate there. Can you really have a good system with interactivity with not making the tools so complex? But like I said, we are getting to a point in which I would say that maybe translators are losing a bit of their patience, because things are getting increasingly complicated. So tools that should be there to help us are sometimes just getting in the way. You know, you have to click this before you do that, and then the result is more or less the same that you had before.
The question of what motivates these design decisions comes to mind. So we have some questions from participants. Judith Brenner asks, in the post-editing mode, Is selecting the type of edit before actually editing the text a realistic representation of what translators do in post-editing?
No, of course, like I said, this was a very experimental interface that we didn't even have time to pilot test before we actually showed it to the participants. So the advantage of this is really almost pedagogical, because at the end of the workshop, people were saying, yes, now I can think about what I do in a more detailed way. Maybe I can look at each sentence that I have to post edit and first think, should I start by deleting extra words, or should I move them from their positions? So it is not, we haven't reached naturally the best interface. It isn't workable in a realistic scenario. No.
A question from Marta Bartnicka. Was there a correlation between translators perceiving autocomplete mode as faster and their actual productivity improvement?
We analyzed the two modes compared to each other, but also comparing the different sessions. And the mode in which we saw a bigger improvement in productivity was actually in post-editor mode. So there was a big improvement from the first sessions to the final sessions. But of course, the autocomplete mode is faster, but we couldn't control that so well because the post-editor mode was new and most of the translators had been using predictive writing and in different tools. So that also helps them being more productive with that interface. But I should also say that even the autocomplete mode was experimental. We were using just one dictionary of the most frequent words in Portuguese, and it wasn't so helpful at all.
And user experience is yet another variable, I suppose. One final anonymous comment. Using own tools also means that the results may not be transferable to the real world. This is not just about comparability between research tools. Absolutely,
yes,
don't you think?
Yeah, of course. Yeah, the main purpose here was really to bring up themes for discussion. You know, bringing up this question about the relation between speed and the how you work, or between text and how we the different criteria that we use to classify translators. So it wasn't so much to get the applicable data to the industry.
It's always a delicate balance, isn't it? Trying to get some sort of equilibrium between ecological validity and limiting your variables so that you can actually test what you want to test.
Yeah, that's the problem in the industry, right? That they tell you they are testing something and sometimes it's not really what they are testing, right?
Anyway, so that's, I think we better move on. So thank you very much indeed, Felix. And Anna, I'll pass across to you.
Yeah, thank you, Felix. Say hi to the people in Surrey. And now we are going to, I believe it's Maria Statimiotti that is going to talk about different, the assessment. And I think the sound from Maria is maybe, she's going to discuss, yeah, I think there is something going on with your sound, isn't it?
No, you can hear me well?
Not really. Can you hear her, Josh? No, now you're...
I hear a lot of distortion.
Yeah.
Okay.
There is like a background noise.
It's a bit like watching the Greek votes from the Eurovision when I was about 5.
No, that's not true, John. It's probably due to the headset and the microphone, but I don't have another one. And
okay, so if there is a problem, I will let you know. Yes, but you're going to discuss different engines assessment in the English to Greek language combination, and this is work done with your colleagues, Vilemine Sosoni, Katia Kermanidis, and Sespoina Mouratidis. Thank you.
Exactly. Thank you. Just a moment. I will share my screen in a minute. Can you see my screen?
We can indeed.
Okay, so thank you. My name is Maria Stasimiotti. I am a PhD student at the Ioannina University in Greece and also a professional translator for more than 10 years, working in the areas of translation, quality assurance, and post-editing. I'm here today to present you a study I carried out together with my colleagues, Vilhelmine Sosoni, Despina Mouratidis, and Katia Kermanidis, regarding the evaluation of 3 different MT system outputs for the English to Greek language pair based on both automatic and human evaluation metrics. We all know that latest technological advances in machine translation have led to a wider availability of machine translation systems for various language pairs, while neural machine translation has been widely hailed as a significant development in the improvement of the quality of MT output. Given that NMT models have been proven to consistently outperform statistical machine translation models. In addition, generic machine translation systems, which are general purpose systems trained with huge amounts of data from various subject areas and domains, provide a reasonable quality for many language pairs. However, they do not perform particularly well for domain and user-specific text and are much less effective than custom-trained models, which in most cases produce better results. Thus, the performance of machine translation systems, the quality of their output, and the types of errors included therein vary considerably, as has been reported by several recent studies based on automatic metrics, human evaluation metrics, or a combination of methods. Drawing on these studies, and in an effort to compare the quality of NMT output to SMT output and that of tailored NMT output to generic NMT output in the English to Greek language pair, we carried out a comparative evaluation of 3 different MT systems following a mixed methods approach. In particular, automatic metrics, as well as human evaluation metrics, including eye tracking and keystroke logging data, side-by-side ranking of the MT outputs, adequacy and fluency rating, and error classification were used. More specifically, as you can see, the automatic metrics used in our study were bleu, meteor, wear, and tear. The effectiveness of using eye tracking as an MT evaluation technique has been proven by previous studies. In the present study, the participants were asked to perform full post-editing of the MT output of 4 semi-specialized texts, while their temporal, technical, and cognitive effort were registered using a Tobii remote eye tracker and the Translate2 software. The texts were presented to the participants in a random order, with the source text being displayed at the top half of the screen and the MT output at the bottom half. After the post-editing task, the participants were asked to rank in order from best to worst and rate for adequacy and fluency all the segments of its MT output for all 4 texts, which was in total 87 segments, and also perform a classification of all the errors found therein. Each participant performed the task in one go, starting from the post-editing task and moving on to the ranking, rating, and error analysis task. The experiments were carried out during spring semester 2019 at the Department of Foreign Language Translation and Interpreting. 16 students enrolled on the MA in translation participated. They were all female. The majority belongs to the age groups 18 to 24, 25, and 25 to 34. The majority had an undergraduate degree, either in translation or another related field. Only 4 of them had experience in translation, while none of them had experience in post-editing. Given that none of them had a previous experience in post-editing and that post-editing training was a prerequisite for participating in the study, specific training in post-editing was offered in the context of the compulsory module translation tools. And here you can see some details about the source text used in this study. These were 4 short semi-specialized texts about the EU elections in 2019, selected for the British daily newspaper, The Guardian, and they all had comparable exile scores. And the details about the MT systems we compared. As I said, we used 2 generic empty systems and 1 custom trained system. The first generic empty system was the statistical machine translation system developed by Google. The second generic empty system was the neural machine translation developed by Google.
Sorry,
And
Maria. Maria,
yes,
your maybe you should turn off the camera because it was frozen anyway. So maybe that's taking a lot of. You weren't moving, so and we hear this noise. So maybe if you without the camera, let's see if the sound is better.
Okay. I will now proceed. As I said, the second generic empty system used was the neural machine translation system developed by Google. And the third one was a custom trained system developed by Canavos and Natalis with the NMT toolkit and trained with publicly available parallel corpora in the domain of the EU. And now I will proceed with the findings, and we will see how the systems perform, starting with the automatic evaluation metrics. As you can see, the tailored NMT system outperform the generic systems, while as far as the generic systems, the NMT performed better than the SMP in all cases. And now we will move with the measurement of post-editing effort. And as regards the temporal effort, we measured the average task time the participants needed to post-edit each empty output. And as you can see, the empty output generated by the tailored NMT system required less time for full post-editing compared to the empty outputs generated by the other 2 generic systems. Similarly to temporal effort, the participants perform fewer keystrokes when post-editing the tailored NMT output compared to the keystrokes performed when post-editing the empty output of the other 2 generic systems. And as far as the cognitive effort is concerned, the tailored NMT output performed better in terms of fixation count, gaze time, and mean fixation duration. Moving now with the side-by-side ranking, you can see we observed that the tailored NMT output was ranked as the best, while the SMT output was ranked as the worst by the participants. As far as the adequacy and fluency are concerned, the tailored NMT output was rated higher for both adequacy and fluency, followed by the NMT system. And now we'll proceed with the errors. As you can see, the tailored NMT output contained the lowest number of errors overall, while the SMT output contained the highest number of errors overall. And as far as the types of errors are concerned, we observed that all MT outputs contained more errors at the level of fluency than at the level of adequacy. As regards the category of fluency, the SMT output contains significantly more grammatical errors than the NMT output and the tailored NMT output. While as far as the category of adequacy is concerned, the tailored NMT output contained slightly fewer mistranslations, terminological errors, and additions, but more omissions than the NMT and the SMT output. So the analysis reveals a higher score for both the generic NMT and the tailored NMT outputs as regards automatic and human evaluation metrics, while the tailored NMT output faring even better, with the tailored NMT output faring even better than the generic NMT output. In addition, the tailored NMT output was ranked as the best and was rated higher for both adequacy and fluency, a fact which explains the reduced temporal, technical, and cognitive effort expended during the post-editing task. The findings point to the fact that there are limits to generic empty models, as they are not tuned to provide translations that are unique to a specific genre and thus tailored to the needs of a particular business or industry. Although the development of a tailored NMT system can be particularly compute intensive and therefore too expensive and time consuming, especially in cases where there are not enough parallel data to train a new good quality and appropriately adapted system, the higher quality and the reduced cognitive, technical, and temporal effort suggest that it is worth exploring further. That was it. Thank you for your attention, and I'm here to answer your questions.
Thank you, Maria.
I will try to open
you can open. In fact, the sound did not improve when you turn off your camera, so we are better off seeing you. So while people we wait for the questions, I was curious about the eye tracking because we have all done our experiments in eye tracking, and so the participants go. It was a Tobii eye tracker.
Yes, exactly. It was a remote Tobii eye tracker.
So did they go to a place, or were they working from home or simulating the home, or how did that happen?
No, we set up a specific environment at the university. We used the quiet room with blackout lights at the windows, no artificial light or only artificial light, I'm sorry, no noise, and they were asked to perform the eye tracking experiment at the university.
And that was separate than the rest? Or?
Yes. Yes, they started with the eye tracking experiments, and then they moved to another classroom where they could answer the questions about ranking, rating, and error classification tasks.
So everything was happening on site to be able to eye track them.
Yes, exactly.
Okay.
We know that this is a limitation. It's not the normal working conditions of a professional translator, but it was the best way to collect and be sure that we collect good eye tracking data.
Of course. Yeah, that was my curiosity, because some people are using, these mobile eye trackers, or they, and then, yeah, but then you have the other problem of not having reliable data.
Yes, exactly.
Okay, so this is an interesting language combination, because it's English to Greek.
Yes, exactly. There are no, from what we know, there are no studies for this particular language combination comparing tailored custom-trained empty systems and generic empty systems. There are only a few of them carried out by me and Vilhelmine Sosoni, and also by Sila Castillo from the Tramuk project in 2017, comparing SMP and NMT systems. But there are only a few studies for this language combination.
And do you think this is out of my curiosity, but do you think freelance translators in Greece are using more and more machine translation, or is it still not the preferred option?
They are starting using more and more machine translation. In fact, many LSPs have started creating their own machine translation systems, from what I know from our colleagues in the industry. And from some questionnaires, not only in translation students, but also in professionals, they do recognize the improvements in empty systems, and they are more positive to use machine translation and perform post-editing tasks.
Okay. Josh, do you have any questions? There are some coming in now.
There's one cropping up there, and I did have one question, and that is to do with your methodology. So, Maria, you said you were using mixed methods, and I wanted to ask which mixed method variant you were using. Did you have a weighting for one or another, or was there a different sequence, or were you trying to triangulate a lot of different things that you were gathering at around the same time?
We were trying to use different methods and gather them at the same time. As we said, there were automatic and human evaluation metrics, including eye tracking, ranking, rating, and error classification, and to see if they do all agree and have the same results for one system.
Thank you.
So Judith Brenner is asking or is saying that other studies comparing SMT and NMT show a drop in BLE scores while you had an increase, indicating that BLE underestimates NMT. Do you have an explanation for that?
Actually, I can go back to that slide. There was not a drop in case of NMT. If we go back to the slide of the automatic evaluation metrics, you can see that Taylor NMT was the best as regards the automatic evaluation metrics. NMT was the second and SMT was the worst. So
that's pretty much as expected, right?
Yeah, maybe it's another metric that you did so, because the slides were going fast. So I'm checking the other ones if there is any drop.
Okay.
Not really. Maybe the VER here score is the only one that drops in the Taylor NMT. From NMT to Taylor, but. So Judith, if you want more clarification, maybe you can take this up in the Slack.
Yes, and there are also more details about statistically significant differences between the systems in our paper and the proceedings. And of course, I will be happy to answer any more questions in Slack.
Yeah, Judith is saying that the blue score for NMT is higher than for SMT, but in other studies, the blue is lower for NMT than for SMT. Oh, okay.
I don't know why this was the case, but what we did in the present study is that we used more than 2 reference translations to compute all these automatic evaluation metrics. Because we know that using only one introduced bias, and but these were the results we received.
Yeah, and VER should go down, Andy. Yes. So thank you, Maria, for your presentation. Sorry about the sound. It was a pity.
I'm sorry for the sound.
But that's part of the online world. So I think it's over to Josh, isn't it?
Yeah, thanks, Anna. Thanks very much, Maria, and greetings to Wilhelmine and Katja.
Thank you, John. Sure.
So up next, slightly, well, 2 minutes early, but I think that's reasonably okay. Our next presentation is by Matea Arnisek. Apologies again for my pronunciation. And Alenka Unk. I don't know if Alenka is online, but she was.
Alenka is very much involved in the TEF. She was actually moderating one of the tables there. So
I saw her moderating while I was on my lunch break from EAMT.
Exactly. So I'll be doing the presentation on my own. I'll just set things up.
No worries at all. So Matteo will be presenting about levels of satisfaction from a multi-dimensional assessment of e-translation output for English Slovene. So Matea, the floor is yours.
Okay, so well, good evening to everybody, and thank you for everybody who's still there. Thank you for tuning into my presentation, and thank you to EMT for having me present this paper, which covers basically the same topic, experience of translators of the E-Commission with e-translation. This has already been presented today, but for a different department, so a different language combination, and with a different approach than what Karolina presented this morning for the Polish, and what our colleague Agnes Leszniak presented at the last year's EMT for Hungarian. So my name is Matea Arnisek. I'm the Quality Officer of the Slovene Language Department of the Directorate General for Translation of the European Commission. I've written the paper I'm about to present with my colleague Alenka Unk, the Language Technologies Coordinator of the department. Together we have assessed the English-Slovene output of the Commission's neural machine system e-translation based on 2 user satisfaction surveys in our department, errors in the machine translation output that had been reported to us by the translators, and an ex post analysis of a small sample of our texts. But first, for some history. So Directorate General for Translation, DGT, had been using machine translation since the 1990s. Then in 2010, DGT started developing MT-ETC, machine translation at European Commission, a statistical machine translation system based on the Moses open source translation toolkit. MT-ETC became fully operational in June 2013. In the Slovene language department of DGT, we started using MT-ETC already in 2011, as soon as the English-Slovene engine was available. In a DGT survey in November 2012, the majority of users of the English-Slovene MT-ETC output already responded that they used machine translation for around 50% of their translation jobs. So it was a regular tool in the department. Then in 2017, e-translation, a neural machine translation system, was launched to take over from MT-ETC. Engines for different language combinations were then progressively added. And in April 2018, the launch of the English-Slovene NMT engine was announced, and interested members of our department started testing its output right away. We received some training on NMT, and the department then invited all members of the department to testing. 3 months later, so this was at the end of the June, beginning of July 2018, a survey was carried out in the department that showed that the use of NMT was widespread and preferred to the use of SMT. So the whole department started using NMT as the default machine translation for a trial period of 3 months. After those 3 months, in November, a new user survey was carried out online that confirmed that users were satisfied with NMT, and the use of NMT as the default engine was confirmed on a permanent basis. Just before this second user survey, DGT had launched an assessment exercise to gather general opinions in the department on how useful neural engines are and what kind of impact these engines can have on the efficiency of the translation process and quality of the translation product. To prepare the Slovene department's contribution to feed into this assessment, in April 2009, I carried out an ex post analysis to check the quality of NMT, and included in the assessment also the results of the 2 user surveys and an analysis of the NMT errors reported. So first, a couple of words about the user satisfaction surveys. The first one was carried out at the meetings of the 2 Slovene language department units. And at that moment, both units combined had 51 active translators and 2 trainees, 39 of whom attended the 2 meetings and 35 responded to the survey. It transpired that most already used NMT at that point. Only 3 respondents actually did not use NMT, and all the translators who used NMT liked it better than SMT, except for 1 respondent who answered that they didn't really see the difference in the usefulness between SMT and NMT. In November 2018, an online user survey was carried out among all 55 active translators in the department. Out of the 43 respondents, 29 used machine translation with every or almost every translation. Another 7 used it often. Only 2 respondents rarely used it, and just 1 replied that they never used machine translation. All 43 respondents, even those who rarely or never used machine translation, expressed their preference for NMT over SMT. As you can see, both surveys actually just gauged the uptake of NMT and how it compares to SMT. In neither were there questions about the quality of machine translation as such. But in the free comments submitted, translators in general felt that NMT was better than SMT. They said that SMT might be terminologically more consistent, but because of incorrect inflections and the strength, they preferred NMT, and also the sentence structure in SMT closely followed the source language, sometimes to the point of mistranslation. This meant that translators had to edit the text heavily, which makes room for oversight and the possibility of introducing new errors in the process of correcting the text. Translators did also note that NMT errors might require more attention and concentration, as they are not easy to spot. Some reactions pointed to the method of using machine translation, which in our department has always been left to the discretion of the translators. So besides using it as a typing aid, so based on an autocomplete functionality as described in this comment, the translators can also use individual segments and post-edit them, look up the machine translation results in concordance searches, or apply a combination of these methods. It is also possible, of course, to pre-translate a whole document using machine translation and post-edit the result, but I haven't come across such use in the department. Translators also complained about some initial technical problems we were having with getting the NMT output, which have now mostly been solved. So there's not many occurrence of that. And what I find important is that they also voiced their need for written aid and training for working with NMT. So the next element of our NMT assessment was analysis of errors. Since the first user survey, department members were invited to report any examples or noticeable or repetitive errors. Then their contributions were gathered into a list, along with possible causes and explanations that could serve as useful tips to users when working with NMT. Over time, this list has been split into sections for different categories of NMT issues. It's our own making. To ensure a more objective and maybe more comprehensive insight into the usefulness of NMT, I also carried out an ex-post analysis to check the quality of NMT. The analysis confirmed the occurrence of errors that had already been reported. For certain categories of errors, the examples found during the ex-post review offered better granulation, and the ex-post analysis also showed examples of some other types of errors that had not been reported before. So we extended the list of categorized reported errors with additional examples and added to the list new categories of recurrent problems, so that the list now paints as comprehensive a picture as possible of all potential English-Slovene neural machine translation pitfalls. These are now the categories into which we've split machine translation errors and issues. I'll give some examples we found of semantic issues and of terminological problems. I'll present some neural machine agent creations, which we've dubbed neural neologisms. Then I'll show also some omissions and additions that neural machine translation produced. And I'll talk about example of the engine's struggle with anything capitalized, such as proper nouns and abbreviations. I'll also show some cases of neural machine translation errors with complex structures. NMT also has problems with incomplete sentences, for example, in bulleted content or in tables, and with or around punctuation, especially around hyphens or dashes or text in quotation marks. Oh, that was so fast. So, but these two last categories are rather minor, so I won't show any examples of that. So to start with the polysemic misinterpretations, which means words in the NMT output where a word in the NMT output is the translation of the wrong meaning of a polysemic word in the source. For example, a swing translated as playground equipment instead of a statistical fluctuation, or race translated in the meaning of a competition, but when the context is about not discriminating based on nationality, age, race, or religion, race here, of course, refers to categorization of people. This phenomenon invariably produces also terminological errors, which I'll talk about a bit more in a minute. Next category are completely wrong words, and we've observed that some of these seem to come from mix-ups of similar looking words, so not actually related, but similar looking. So the similarity might exist in the source language, for example, we had examples, an example where slavery was translated as something which back translates as Slavic, or skills were translated as ubijanje, which back translates to killing. The similarity is sometimes found in the translation on the target side. So we, for example, we had moving away, which could be translated as odmikanje, was translated as odmiranje, which back translates as dying off. Some semantic mistakes at least concern words that might appear in similar contexts. So we had Cypriot translated as Europski, European, so both sort of geographical adjectives. And for some errors, we could make no observation as to their origin. For example, hosting in the technological context was translated as počitek, which back translates to rest. When it comes to the next issue, terminological problems of NMT, we found generic words instead of terms sometimes. So for example, in a document on protected geographical indication, opponents were translated as generic adversaries, antagonists, instead of the domain-specific term for persons who oppose the registration of such a protected geographical indication. Sometimes NMT would also contain just the wrong term. For example, in an act on the service of judicial documents, service was translated in the economic sense instead of as delivery of service, handing of service, of document. And as others have before me have shown, NMT can be highly inconsistent, which is especially problematic when it comes to terminology, because this demands consistency. So we had, for example, in a sample document in the exposed, we had operators in 2 consecutive sentences translated with different valid terms, but stemming from other areas of regulation. Here are a couple of examples of neural neologisms, so words invented by the NMT engine that do not exist in Slovene. If we look at Reformed Protestant Church, the word Reformed, for example, was translated as retvorna. So apparently the elements of the word in the source text were identified. So the prefix re in Slovene is also used. And the second element, formed, was translated into tvoren, which could make sense as a Slovene translation. And the feminine gender ending was actually correctly applied to the end. So this is how you get retvorna. On the other hand, in the phrase becoming a Maltese citizen, becoming was translated as popolanje, which is a non-existent word with no apparent semantic association with any meaning of becoming, but still with the expected gerundial ending, which makes the word look Slovene. Next category, so omissions and additions. As I said, NMT omits some words, for example, elements in longer enumerations, for example, lists of countries. And sometimes the omission can even produce the opposite meaning in the translation, because sometimes what is omitted is the negative particle, so not, never, or similar. And sometimes NMT also omits whole parts of sentences, which is not something which we saw with SMT. And while at the same time NMT still retains the fluency, which makes it, sometimes hard to catch. On the other hand, NMT also adds words or elements in a sentence, which also includes repeating elements. So for example, we had in the document the Portuguese-Spanish border translated as Portuguese-Spanish border. So then to capitalized content. So NMT might have problems with proper nouns. We can assume because they tend not to be repeated that often in our documents, which is the data on which NMT is trained, and their translation is guided by different rules than that of common nouns. The result is that the engine changes proper nouns by adding or switching letters, or tries to actually translate them, as we can see in the example of the City of Christchurch, translated as Božična Cerkev, which back translates to Christmas church. NMT also has trouble translating abbreviations. So in a document on corruption, we had CPC translated as Communist Party of China, whereas it should be Corruption Prevention Commission. This problem is exacerbated by inconsistency. In one of the documents I checked in the ex post, CA, which stood for Certification Authority, was translated in 6 different ways on the 2 consecutive pages, and only 2 of those were actually valid translations. A very recent example, not in the paper, was the way that COVID-19 was translated in NMT when the abbreviation first started appearing in our texts, which just shows that all sorts of codes formed of combinations of letters and numbers, also chemical formulas, need to be checked in an NMT output. Then complex structures. NMT has trouble with structures with implicit relationships between words, such as long compound noun phrases in English. Short-term travel possibilities, for example, could be understood also by human translators as either short-term possibilities for travel or possibilities for short-term travel. But on the other hand, NMT exhibits the same behavior also where no human translator would misunderstand the relationship. As in the case of benefits of earlier hepatitis and HIV testing, which NMT translated as benefits of having hepatitis earlier and of getting tested for HIV. A problem also occurs with structures which actually have explicit relationships between them, so prepositions. And we've had examples of requirements on small and medium enterprises translated as requirements of small and medium enterprises. Now for an attempt at a bigger picture. So document samples for the ex post analysis included legislative, non-legislative, and general public documents from different domains. So the analysis also provided some insight into the usefulness of NMT for these different document types. However, the document sample for the ex post analysis was small. We're talking about 2-page extracts from 3 to 4 documents per category, altogether 20 pages. And so possibly the sample wasn't representative for the categories. So in the sampled legislative documents, in the acts, the biggest problem were terminological errors and inconsistency, but generally not so many edits were necessary. On the other hand, in a terminology-heavy annex to a legislative act, the terminological errors and inconsistency made NMT completely useless, especially because there were tables with fragmented text and many abbreviations. It was much easier to translate from scratch than post-edit the machine translation. In the sampled non-legislative documents, terminology was still problematic, but as these documents are less terminology heavy as a rule, machine translation produced fewer errors. Domain-specific vocabulary still remained problematic. NMT suggestions needed the most edits in the sample documents for the general public. Although terminology in such documents is mostly unproblematic due to the less standardized vocabulary, complex structure, metaphorical language, NMT suggestions were mostly useless. In segments with problematic elements in the source, NMT output was poor not only due to handling these problematic elements badly, but also did worse in the aspects where it is usually superior to SMT. For example, we were seeing again incorrect inflections and awkward word order. This finding of relative usefulness of NMT for these categories goes against what many of our translators feel, which is that they find NMT the most useful for text for general public. Besides the problem that the sample might not have been representative, this could be due to the fact that legislative documents are still the bulk of our source texts. So there is appropriate material in NMT engines training, which might then produce better results for these than for other types of documents. But the nature of these texts, the legislative texts, makes any errors critical, which might contribute to the translator's assessment. In conclusion, so e-translation is widely used in our department and is highly appreciated by the translators. They have from the start felt it to be a better tool than the SMT that we had been using before. Nevertheless, it had been clearly demonstrated that NMT is just a resource for us, a tool, not the final product, against the high standards required for commissioned translations, which are intended for publication and have legal consequences. The reported errors revealed a variety of problems in the NMT output, and the ex post analysis confirmed that NMT output cannot be used as is. None of the documents in the sample, when simply pre-translated with NMT, were fit for publication. How much time, if any, is saved by machine translation remains unknown. We didn't test that. And the same goes if the use of NMT saves time in comparison with the use of SMT. So even though translators prefer working with NMT to working with SMT, I couldn't claim that NMT use is necessarily easier and that it accelerates the translation process when compared to SMT. The use of NMT involves also different types of issues that need to be dealt with and might be considered more mentally taxing than those inherent in the use of SMT on higher levels of grammar or beyond grammar. So clearly, a skilled human is needed to guarantee a high quality of translation fit for publication. This means NMT as a tool needs to be understood better in order to be used better, which requires educating and training the users. So we've organized a department level training to familiarize translators with the list that I presented to you and with the results of the ex post analysis. We intend to update the list occasionally with new examples to keep things fresh and to repeat the presentation if needed. We might also look into organizing a post-editing workshop if there is a need for it. So with this, I conclude my presentation and I thank you for listening to it. And I am here for any questions or comments.
Thank you very much, Matea. Interesting that disambiguation of polysemous words is still problematic after it being first written about by Yehoshua Bar Hillel almost 70 years ago. And it's something that we see still cropping up every so often. I have a number of questions. First from Andy Way. Megan Dowling spoke earlier about Irish, and we're talking to the Irish DGT translators. We hear from Carolina before that about Polish MT. What opportunities do you have in the DGT to share experiences, and how often are those shared experiences across different language groups, and how does that get fed back to the e-translation developers?
Okay, in the DGT we have actually two networks which would deal with the assessment of quality or the use of machine translation. One are the language technology correspondents that, like, who, you know, my co-author Alenka, who are responsible, who are the contact points in the department for matters relating to language technologies, translation tools and resources, machine translation among them. And the other network is the quality officers. Myself and Carolina and Agnes, who presented the experience of the Hungarian department last year, we are all quality officers. I did see, I mean, for example, Carolina has presented her work on NMT to other quality officers. So there is the sharing of information. But for example, in the DGT, but for example, I didn't know that she actually wrote the paper for the conference as well. So I still have to read that because I found out when I saw that she has a presentation as well. So there is some more sharing that we can do within the DGT, but anyway, the things that we are seeing, the ex post analysis that I wrote was prepared for the quality managers of the DGT and for the machine translation user group. So all the findings that I listed here were shared with the MTUG, and there. So this does get back into the loop. And if there's any after any update of NMT, after any if we start seeing new problems, I know that there have been rollbacks to previous versions. So they are very responsive, and they take our observations into considerations really quickly. I hope that answers the question.
I think so. Thank you. So speaking of Carolina, a question from her. Do you have examples of language-specific errors or problems which result from the linguistic features of Slovene?
So language-specific errors. Well, I mean, there would not really. I mean, I could see correlations with, at least with Croatian or with other languages, inflectional languages, that that the similar problems occur, and also from the from other departments, I see that we are actually encountering same problems with it. The omissions, the additions, they happen. The newly invented words. I know that there was a Dutch study where also they found that grace was translated as graze. So it's amazing, but the same phenomena seems to be happening regardless of the target language.
Yeah, a lot of those neologisms seem to be to do with byte pair encoding, where words are broken down in training into chunks that aren't necessarily linguistically motivated, and it means that the idea being that the system should be better prepared to create or to produce compound words, but it can produce words that don't really exist, or there can be things that cropped up in Eva van Massenhoven's PhD where I trained was translated as it rained. So those seem to be common across different language pairs. A question from Judith Brenner. What do you think your translator, or let me see, do you think your translators like to use NMT as a tool? Where do they see the benefits for them? I might add to that, how do they like to be served MT outputs?
Okay, so as I already first part, so why do I think the translators like using it? If that was the question, if I got it right, I think as Carolina already said, the SMT, although more consistent, it was more linguistically, how to say, rigid. So we had problems with inflections and endings. So that annoys translators. It gives you a lot to do on things which, correcting endings. And it's, and if you don't do it, if you do it in a hurry, then you introduce mistakes. So this wasn't ideal. So that's why one of the main reasons I think that people prefer NMT, because of the fluency, because there are fewer edits necessary. To make it seem okay. Although, as I said, the terminology in legislative acts makes some people not want to use it, although because they are afraid they would be misled by the suggestions, and they would forget to check it because the translation is already there. And Joss, you asked about how they are served. So basically, we have a pre-processing system, which means that for every original that comes to our service, the document is sent to each translation, and before we start working on it, we get the neural machine translation, the TMX, in our system, and we import it into our project as one of the reference memories. I mean, as one of the reference memories with a 25% penalty. And then, as I said, it is left to the translators, who might also decide on case-by-case basis how to use it. Some use it in full segment mode, so inserting the segment where you wouldn't have any reference material and then post-edit it. Some prefer use it as a typing aid, so using it in the autocomplete option. And but as I said, and nothing prevents us from using it with the I sometimes use it for to get some another idea than the one that is rolling in my head, so I might use it in concordance searches. And of course, nothing prevents us to fully pre-translate a whole document with machine translation, but I think that either because we're not fully trained for that, or because it actually isn't the most efficient way to doing things, I have not yet talked to a translator who would work in this way in our department.
It's interesting that you say that. It's nice to see a different way of expressing something, because often you hear translators or participants in research who have pre-populated MT saying that once they see the MT output, it's hard to think of how to express that same notion in a different way. Whereas if you have an idea in your head first, then it's an alternative as opposed to the primary
Exactly.
option.
I mean, as Carolina says, we are fans of machine translation. I mean, we are professionals, but this is, you know, mostly what I see is people judging machine translation, neuro machine translation, whatever machine translation, as the final stage. Yes, so what you get in Google Translate, which is fine if you need a basic understanding for gisting, or if you need, you know, because this is better than nothing, or if you, you know, need to decide on further processing the document. We use it differently. The professional translators use machine translation differently than common users of Google Translate. So our appreciation for machine translation as a tool still does not prevent us from maybe disagreeing with certain, you know, certain decisions that certain pages or certain documents are, you know, only machine translated, even especially if it's without any post editing at all.
Yeah, so it's MT for dissemination rather than assimilation.
Exactly.
So a final question from Martin Pasiak. Thank you for an insightful presentation. Do you plan to follow up on your assessment? And if yes, do you plan to broaden or change the scope?
Well, I didn't actually plan very much on doing so, but I got a couple of ideas now here. You know, because the test that Carolina did on the productivity gains, we haven't looked into that at all to see if it would, to see how exactly we benefit from most from machine translation. So if we redid our assessment, we would definitely do it in a different way, you know, to check for other things, not for, not, you know, to just see what kind of errors there are. Although in a little longer scope, maybe we could also, a new exposed will be in order, but it will have to be a little larger to see if the errors that we were seeing last year are still there after, you know, the retrainings of NMT.
There are remaining questions, but I think we better move on. The last questions were related to that, from Veronica Keck about what technology is used most and statistics using MT versus TM, and also how you differentiate between the MT output when it's in TMX. But there is that 25% penalty, so I presume that
yes,
that
and
helps on that front.
it also has a, I mean, we're using Studio, and it has
so it's marked AT.
A marking AT, so you would clearly differentiate it from other input.
Thank you very much, Mateja. And I think we can take these questions in a Slack. And I would like to introduce, so they don't, I know it's the last one, but thank you to everyone to still be here. I see a lot of participants, and it's late in some countries and maybe early in another. So our last presenter, it's Randy Scansani, and he will give us an insight on the way LSPs compute pricing for post-editing. And I must say, this is a very, very generous of them to show this internal process in the company, because it's not very common that companies reveal how they pay translators. So thank you very much, Randy. The floor should be yours, although I still see Mateja.
Can you see me now?
Yeah,
okay.
You are here.
Hi. So I'm sharing my screen. Okay. Despite the increased and always increasing use of machine translation in the translation industry, the translation companies haven't moved towards standard and shared practices to estimate post-editing discounts. And this, as you can see from these few examples, led to a pretty confusing scenario, especially from the point of view of post-editors. And in the long run, it might even become a threat to the sustainability of the whole industry. On the one hand, it is true that, especially thanks to the user and translator tracks introduced in the main machine translation conferences, companies have started to reveal more details regarding what they do, regarding their practices, and to discuss this, for example, with the research world. But to the best of my knowledge, and as Anna was also suggesting, so far this hasn't happened when it comes to the pricing models for post-editing. So there would be a need for shared practices to estimate machine translation discounts. And of course, this topic is strongly linked to the output evaluation, because if you ask a post-editor to reduce his or her rate when doing post-editing with respect to when translating from scratch, then the rate reduction, of course, has to be in line with the quality of the output you are providing to him or her. So what I'm going to present is the pipeline that we have developed at Accolade to estimate machine translation discounts. When we started to build our pipeline, of course, we started to look at what we already had to measure, to assess the output quality. So we looked into automatic metrics. We looked into the standard quality frameworks that are used for human evaluation, DQF and NQM. But in both cases, we ended up with the same issue. That is to say, how would you interpret these measures, the outcome of these measures, with a view to computing machine translation discounts? That is to say, what does it mean exactly if you have a 30% ER? So we know that if a 30% ER that is mainly influenced by, for example, terminology edits, has not the same impact on productivity than a 30% ER that is mainly influenced by other edits, for example, simple morphological edits to correct concordances. At the same time, if you have a low adequacy score and a very high fluency score, what would that mean in terms of productivity? Because if you are doing machine translation post-editing, it means that you are aiming at reducing translation costs and translation time. And if you are not able to do that with your output, then why applying machine translation at all? So you need to care about productivity. So what we ended up doing was trying to think about how we were intending the concept of quality, because automatic metrics, standard quality frameworks work to measure, let's say, the output quality or the translation quality in general per se, but it's hard to define quality, and you need to find the definition that suits your needs. So the definition needs to be based on what you're going to do with the text that you are assessing, basically. So for our aims, we defined the output quality as the extent to which the machine translation output helps the translator be more productive. So I'm going now to present our pipeline. And our pipeline is mainly composed of 3 steps. The first one is actually only an introductory step. It doesn't impact the discount that we are going to apply. The second and third steps are one manual evaluation step and the real condition test. I'm going to provide the details about this in the next few slides.
So these are the two steps, these are the two core components of our pipeline. And these are the components that then influence the coefficient that we applied to word-based rates. And I'm going to explain all of this in a few minutes. What I wanted to also to stress is that what we do with our pipeline is to apply this pipeline to each engine that we train or retrain. So this pipeline is repeated every time we have a new engine, and we come up with a coefficient that is specific to that engine. And at the end of the test, we also ask posteritors to fill in a feedback form so that we are able to collect structured feedback from, let's say, the final users of our machine translation output. I don't have time to go into details regarding that, but there are pricing machine translation post-editing guidelines that were published by TOS some years ago, and our pipeline complies with these guidelines, and the details are provided in the paper if you're interested. I'm going now to describe the real condition test, so one of the two core components of our pipeline. So, of course, the name of the test speaks for itself. The real condition test is a test in which we ask a posteritor to perform full post-editing on a sample of 5,000 words. Of course, the post-editor is provided with our full post-editing instructions so that he or she is fully aware of what are the expectations that we have in this particular scenario. Since it has to be a realistic test, we ask the post-editor to work in his or her preferred CAD tool. What are the outcomes of this test? Well, we have one main outcome for our aim, that is the time spent on the task. Thanks to this data, we are then able to compute the throughput, that is to say the number of words per hour. And we compare the throughput in this particular task, in this particular post-editing task, to an estimate of the throughput for translation from scratch, so that we are then able to compute the productivity increase of post-editing with respect to translation from scratch. And in the end, what this test provides is a coefficient. So what is this coefficient? This coefficient is basically the reversed productivity increase. So if we see that in this test we achieve a 30% productivity increase, we are going to have a 70% coefficient. So the higher the coefficient, the lower the predicted productivity increase. And this 70% coefficient is then applied to word-based rates as a weight. And by word-based rates, I mean the rates that are usually applied, that are agreed upon with a translator beforehand for translation from scratch. So the coefficient is used as a weight and applied to these word-based rates. The second core component is a manual evaluation task. And in this task, we use a sample of 3,000 source words that are translated by our engine, of course. And we ask one evaluator to rate each segment of the sample based on a scale from 1 to 4. The linguist that is taking part to the manual evaluation test has necessarily to be a different linguist than the one doing the real condition test for the same engine. And the scores from 1 to 4 reflect the predicted post-editing effort on that sentence in a full post-editing scenario. So why are we using this particular kind of test? We are relying on this for two main reasons. One of the two is that previous works have shown that there is a good correlation between scores predicting the post-editing effort and the actual post-editing time. And the other reason is that with the manual evaluation, we are able to, let's say, have a second opinion, collect a second feedback from a different post-editor than the one taking part in the real condition test. And we are able to do that with shorter deadlines and with lower costs than with the real condition test. once the post editor has rated each segment with the 1 to 4 scores, we then assign the number of words that were assigned to each score to, so we then compute the number of scores, the number of words that were assigned to each score. So we know how many words were assigned to each of the 4 categories, reflecting a different editing effort. Thanks to these numbers, thanks to the number of words assigned to each score, we then compute a coefficient that works exactly like the one I was referring to for the real condition test. So it's reversed as the productivity increase, as the estimated productivity increase, and this coefficient can be applied as a weight to the word-based rates. Once these 2 tests are done, we then average the coefficients of the 2, and so we come up with the final coefficient. Again, this is a weight applied to the word-based rates. But if we see that the 2 coefficients largely differ one from another, for example, by more than 10%, instead of computing the average, we first repeat the tests involving different post editors to see if we are obtaining different results. And then, yes, we have the feedback form to collect the feedback from post editors. I already mentioned this. Maybe I can skip this part because I want to share some examples, some results we obtained with our pipeline. So in this table, you can see the results we have obtained on 4 different engines, customer-specific engines. Of course, I cannot reveal the name of the customers, but these are 4 examples divided into 2 language combinations and 3 different domains. In the first row, the outcome that you are seeing is the HDR, that is to say the edit distance between the raw output and the post-edited version produced during the real condition test. The second row contains the coefficient obtained from the real condition test. And then in the following row, you can see the coefficient obtained from the manual evaluation test. And of course, in the last row, the average of the 2. So there are a lot of numbers here. I'll try and guide you through what are the most interesting ones, at least in my opinion. First of all, what I wanted to stress is that medical English into German is the engine for which we obtained the lowest productivity increase, and indeed the final coefficient is the highest in the table. But still, we can see that the output was able to boost the post-editor productivity by 19%, which is already a good result. Another thing I wanted to mention is that if we compare the HDR and the final coefficient, we can see that, and this is something that I was mentioning at the beginning of the presentation, we can see that there is no correlation between the number of edits performed and the final coefficient, so and the productivity increase. Because, for example, for medical English into German, we have the lowest HDR, so the lowest number of edits were performed. So you would expect the productivity increase to go all the way up. But in fact, what is happening here is that we have the highest coefficient, so the lowest productivity increase. And on the other hand, fashion English into German has the highest HDR of the table, but the lowest coefficient. So higher number of edits, higher productivity increase. To conclude, I also wanted to mention that except for fashion English into German, where the 2 coefficients differ by 7%, in all the other cases, we can see that, that the 2 coefficients are close to each other, which seems to suggest that our manual evaluation method to predict the post-editing productivity correlates pretty well with the actual post-editing effort that we are able to measure on the real condition test. So to conclude, what I wanted to say and to stress is that so the examples I was providing and also the feedback that we collect on a daily basis seem to suggest in general that our pipeline is reliable. But on the other hand, we are perfectly aware of the fact that this pipeline needs constant improvement, that is, has to be constantly refined. And just two examples of topics we want to investigate are, first of all, that what we do now, as I was mentioning before, is to have one discount for each engine. This means that we are not really taking into account differences between post editors in terms of productivity, for example, in terms of experience. And even though it is true that the same happens with the discounts applied to translation memory matches, on the other hand, we could easily try and, at least when the budget and the deadlines allow for that, we could try and add more post editors to the real condition test so that we are able to measure the productivity of different post editors. Another topic we would like to investigate is to see if there are, for example, specific tendencies related to a language combination or the variability inside a specific domain. And if we can maybe take into account these differences, adding parameters and weights to our formulas to compute the coefficient. What we are also working on is collecting a reliably large number of real projects so that we are able to compare all the results that we get on real projects with the test results we have, so that we can see, for example, if we can identify specific weaknesses of our pipeline, and then, of course, if we can work to solve them. And then to conclude, I want to mention, basically I want to conclude with the same thought with which I started this presentation, that is to say that, so answering the question of why we're doing that, why are we sharing these procedures? And the reason why we're doing this is that we really think that the whole industry would benefit from a shared standards to estimate post editing discounts. And if we would move towards shared practices, I think that post editors as well would benefit from it, because of course we can assume that if post editors see that the same task, that is to say a post editing task, is paid based on very different models based on the companies they are working for, maybe this has a negative impact on their perception of the post editing task. So thank you very much for your attention. And of course, I'm here to answer your questions if you have any.
Thank you, Randy. Very interesting indeed. And I'm going to jump quickly to the questions and summarize them a little bit. So, Clara Engine of Art is obviously asking that how many people do you have in your Eamt team? Because this seems to her a huge effort to obtain the two coefficients and then do all the calculations, etc.
So our team includes more or less 10 people. This is let's say the core part of our team, and then we have other people around it. And of course, yes, it takes some effort to have this pipeline in place. But through automation and experience, we were able to streamline it as much as possible. And then, of course, we also think that this is the best way that we have so far to compute the discount. So yes, it takes some effort, but as long as we see that it works, we try and have this effort taken care of.
It's easier then to talk to translators when you have this. I think it's easier to negotiate. So maybe you spend more time in one thing and then you save on the negotiation part.
Well, what I can say from my experience is that, of course, it happens that post editors have some doubts regarding the discounts you are applying, especially beforehand, maybe because they are influenced by negative experience with machine translation, post editing. So they maybe sometimes some post editors say that, in their opinion, the discount is too high. They don't want to work on it. But when you then explain that you have such a pipeline in place, that you did that, and especially that you involved other post editors in this process, then they tend to rely more on the procedures.
You have many questions here. I don't know if we are going to be able to go through all of them, but Dorothée Bear is asking, then which criteria do you use to select these evaluators, post editors, for both the manual evaluation and the real condition test?
Of course, we look for experienced post editors, especially for the real condition test. And we are able to identify all the translators that have accepted beforehand to perform post-editing tasks. And what we usually do, of course, whenever this is possible, is to involve the post editors that are used to work on the specific contents for which we just trained our engine. So, for example, if we have one post editor that is used to work on the contents of a specific customer, and we are developing an engine for that customer, we, as much as possible, of course, based on the availability of the post editor, but we try and rely on the work of that post editor for our tests.
There are some. I'm going to summarize here so you can answer everything, and then people can take it to Slack. But there is this thing, and I think a lot of it comes from not knowing a little bit the industry, but there is this controversy between, shouldn't we be paying hourly rates? Shouldn't we divide, how many words did you do divided by the time, and then you pay people? So what's your take on that?
Well, also some of the questions of the screenshots I was sharing at the beginning of my presentation, I think some of them, they were all taken from pros.com, and some of them were mentioning the possibility of being paid by hourly rates for post-editing. There are two main issues with hourly rates for post-editing, in my opinion. The first one is that the post-editing time is highly variable. It varies a lot from post-editor to post-editor. So it's very different to have a discount or to have post-editing rates based on that, because the price of post-editing would vary a lot for the same output for the same customer. And the second issue, and probably the main one, is that you need to tell to the customer in advance what is going to be the costs that the customer is going to pay for a post-editing task. And if you rely on the time spent on the task, or also if you rely on the TER, on the HDR, post-production HDR, for example, what you are doing is you're not able to estimate the costs beforehand. So the customer does not know how much it will cost that project. So this is why pay the post editors with hourly rates is not really feasible, at least for now. But what I can say is that if I heard that somebody was suggesting to basically measure the throughput, and this is what we are doing. We are doing it beforehand with an estimation, of course, because as I was just mentioning, you need to estimate the prices in advance. But this is the main idea on which we are relying right now.
Yeah, and also you have a budget, right, that you have to comply, and all this is in advance. It's very difficult to leave it for. So I believe that we have to end here because I don't want to keep the overall organization, right, Josh? My colleague in arms.
Yeah, I think so. But
there
that was
were many
fascinating with lots
questions,
of
but Randy,
questions.
because I do think this is very relevant, and this is one of my fights. But so I'm so glad that you came to talk about this.
Okay,
And,
I'm glad to hear that. Yes.
And I will invite the Pascaline and Merton and Veronica Keck and well, Marit, I think we answered your question, and Evelyn as well, and Mikkel, we answered that question, to take it to Slacks. So now I guess we hand it over to the general organization.
Yeah, I'd just like to finish, Anna, by
Oh,
saying
sorry, Josh.
it's just
leaving you
fascinating to
out.
see the different forms of evaluation and the different preferences based on whether they come from research, from institutional translation backgrounds, or from industry. And that's been really interesting this afternoon. And I think there's probably a lot that each group can learn from each other. And to say thank you to the organizers, the contributors, everyone who sent in a paper, Federico, Celia, and Mikkel for asking us to chair, and my wonderful co-chair, Anna. Thank you, everyone.
Thank you, Josh. You're so good at saying thank you, you see. I'm a disaster. Okay, thank you.
Okay, so good evening, everyone. We're going to start the closing session. In spite of the changes that were brought about by COVID-19, this 22nd annual conference of the European Association for Machine Translation, EAMT 2020, has been a great conference. We've had more than 250 registered attendees. It's been the largest EAMT event so far, and by far. Though size is important, I also believe that the level of the papers that have been presented and the discussions they have generated has been outstanding, even in spite of the different medium. In particular, I am very happy to see how the conversation between machine translation practitioners on one side and professional translators on the other side, which was formally started in 2018 with the translators track, has continued. EAMT conferences are getting better and better at bringing together all stakeholders in machine translation and translation technology. Don't worry, I know it's late and I won't talk for long. So first of all, I would like to end my speech here by just saying thank you again to everyone involved, our organizers, our sponsors, the track chairs, the reviewers, the authors, and all of the attendees. In difficult times, together you have put together a conference we can all be proud of. And thank you all very much on behalf of the EAMT. So I'd like to hand it over to the local organizers so that they also say a few words.
All right, thank you very much, Mikkel. So, well, thanks everyone for coming to the conference. This was a challenge to do this year because it's the first time it's a remote conference. It's been, great for us to hosting everybody. I'd like to thank everyone, from the local team, starting by Elena, that always made sure that everything was, in the right place for doing this, and also Bruno Martins, Fernando Batista, and Carla Parra Escartin, Isabel Troncoso. I hope I'm not forgetting anyone. We also had some help from people from Unbabel, Ricardo Rey and Catarina Farinha, who hosted some of the sessions. Okay, I think my connection dropped for a while, but I think I'm back.
Yeah, you're back.
All right. Huge thanks also to all the track shares that worked with us to ensure that each track session was smooth. And this is it. So, does any of the other locals wants to add something?
Just want to say hi, everyone. We would love to say welcome to Lisbon, but was not the case. This was much harder than face-to-face, Andy, that's for sure. I was seeing your comment. But since we were amongst friends, this was a huge pleasure. And this team was a dream team. We know each other from MNLP before. We now had the amazing addition of our Carla Parra, who did an amazing job advertising everything. And this would not be possible without the friends, the local ones over here. So thank you very much to everyone.
Okay, before we go, we have 3 announcements to make, and here they go. Carolina Scarton, Eamt Secretary, will give the first announcement. Carolina?
Okay, I'm going to share my screen if I can find it. Okay, just 1 second. So I'm going to announce now the best paper award of this conference. And just so people understand a bit how it works, firstly, we get nominations from the track chairs. So the 3 research users and translators track, they all nominate the best papers on their opinion, and of course take into account the reviewers and the scores. So after that, we assemble a panel that would take into account not only the content of the paper, but also the presentations. So it was actually decided almost right now, because we need to wait until the end of the conference to make all the judgments. The panel was composed by myself, 1 representative of a track, so Marco Turki, Anna Gabrov Arenas, Mari Nurminen, 1 EAMT executive member, so this was Barry Haddo, and 1 local organizer, that was Andrea Martins. And I'd like to say that we had very high quality papers on this conference, which made our decision, our selection hard. But the selected paper is outstanding because it presents a clear path on how research can be adapted and applied in an industrial scenario. It shows a rigorous evaluation process that included both automatic and human assessment in order to draw conclusions. Bridging the gap between machine translation research and industry is one of the core aims of our association, of our EAMT association, and we believe that this paper has an impactful contribution towards this direction. So the winner is, terminology constrained neuro-machine translation at SAP, Miriam Excel, Bianca Pushback, Laureates Brandit, and Simona Doneva. I don't know if the winners are in the audience, but I think all of us here congratulate them. We are going to contact you soon, so you can have a copy of this certificate. And your prize, of course, is sponsored by Springer. So thank you very much, Springer, to sponsor this. It's worth 500 euros in Springer books.
Thank you very much, Carol, and congratulations to the authors of the best paper. Now I'm going to the second announcement we have is by Steve Richardson, President of the International Association for Machine Translation. Steve.
Thank you, Mikel. Can you hear me okay? Okay. First, I just want to congratulate the EAMT on a wonderful conference. As you know, AMTA held a conference about a month ago, and we have a lot of understanding and empathy for what it takes to put on a virtual conference. And you folks have done a marvelous job, and congratulations. And I enjoyed watching some of the sessions, but it really looks to have been well organized, and the proceedings and everything else that you've got are wonderful. So congratulations on that. As you all know, or most everyone knows, the IAMT is the umbrella organization of machine translation internationally, and then it has 3 sister organizations. EAMT is one, and then AMTA is the other in the Americas, and then AAMT in Asia and Asia Pacific. And each odd year, one of those organizations hosts the MT Summit. Last year it was in Dublin, hosted by EAMT, and it was really well done. I really enjoyed that. I was there. Andy Way was the general chair, and it was an excellent conference. Next year, AMTA is going to host the conference with, we hope, participation from everybody around the world. And I'm going to share my screen and tell you that this is where we hope it's going to be. I can't guarantee. This is just a page from our AMTA website that gives a little bit of information. Actually, this was going to be the location of our AMTA 2020 conference this year, but of course that was canceled and became virtual. And so because we already had an arrangement with the hotel, we were able to defer the locale and the arrangements to next year. It's in August. It's right next to the Disney theme parks there. If we hope that, and maybe we pray too, I don't know, that this pandemic will abate so that we can have a lot of in-person participation. People will be so anxious to get out of the house and go someplace that they will come to Orlando, Florida, and want to enjoy a vacation in public. Of course, if that does not happen, if something, if the thing continues, then we may have to go virtual. But right now, this is our plan. We also, after our AMTA meeting, we had a lot of feedback that even if we did do this in person, there was a strong desire to have a virtual component as well. There are benefits. You can record the sessions, people can watch them afterwards. You can have many more people participating, as you have here. We had more than double what we normally have, and it was a great experience. So the only concern is whether if we do virtual, how are we going to make sure that enough people come that will pay also for the local arrangements as well. So we'll be working on that, but we do invite you all to plan now to attend the MT Summit 18, to be held, we hope, in Orlando, Florida. We'll probably be putting out a call for papers here shortly after the first of the year, and we'll be arranging things. And we look forward to having you all with us in Orlando. If the successes of the previous MT Summit and our AMTA conference and your conference this year are any indication, this should be a wonderful conference, and we look forward to having you with us in Orlando. Thank you very much for allowing me to take this time to make this announcement.
Thank you very much, Steve. And third, the long-awaited announcement from the organizers of EAMT 2021.
So good evening. Here's the mystery man. Let me see if I can share my screen. So I've provided you with a small video. So, yeah, this is Ghent. So after this flashy video of the city of Ghent, which, by the way, Lonely Planet called Belgium's best kept secret, I'm delighted that I'm able to announce today that the 23rd annual conference of the European Association of Machine Translation will be hosted in this beautiful city next year in September. Now, we all know what the current sanitary situation is in Europe and also in the rest of the world, but we can only hope that by next year we will again be able to meet and to speak and to discuss face to face. What the past 3 days have shown us is that technology is perfectly able to handle presentations from a technical point of view. And congratulations, sincere congratulations, and many thanks to the local organizers for this excellent setup. But I think I speak for many of you. I think Steve Richardson just mentioned this as well to some extent, that we all missed, well, the beautiful city of Lisbon. We all missed the Portuguese hospitality, and especially also the socializing with friends over a coffee or during the lunch break. Optimism is a moral duty, so I'm positive. I'm positive that this health crisis will clear away by the summer next year, and that in this way we can organize events on site again. We will obviously closely monitor the situation, and we will be ready to go fully digital if need be. As you can see from the slide, the University of Ghent, via the research group LT3, the Language and Translation Technology team, here represented by Professor Lieve Makke on the one hand, and then Crosslang. I'm Luc Meertens, I'm the CEO of Crosslang, a Ghent-based SME focusing on translation automation. On the other hand, well, we've decided to join forces, and we will be the host for EAMT next year in 2021. We'll try to be as concrete as possible. So we're looking at the second week of September for a 3-day gathering with a tentative date of Wednesday 8 to September 10 next year, September. So I would like to sincerely thank the committee for allowing us to host this event in Belgium. And we do hope to see you all safe and sound in our city, in our beautiful city, as you could have seen a couple of minutes ago, next year. So thank you, Mikel, and thank you all the others from the organizing committee that we were allowed to do this, and we're looking forward to seeing you all there.
Thank you very much, Luc. This is exciting. And also, I'd like to thank Lieve Makke for accepting to be secretly co-opted yesterday as a member of the executive committee on behalf of the organization of EAMT 2021. As you know, we asked the people in the General Assembly to give us a vote of confidence and co-opt someone without giving her name. And so thank you very much, Lieve. And now it's over. On behalf of the EAMT, I'd like to thank you all again. Goodbye. Good luck, everyone. Stay safe and see you in Ghent.
Thanks a lot.
Thank you.
See ya.
Thank you.
Bye-bye. Bye, everyone.
See you, everyone. It's over. Thank God. Love you all, but I need a nice weekend.
You can rest now, Elena. You can rest. Go grab some wine.
See you all.
Bye, Elena. This is still recording in YouTube, by the way.
Really?
just in case.
You're gonna post edit.
And And I'm not able to stop this from recording actually, which is, I think only Bruno can do it.
I will be ending, but we still have attendees
Okay.
here. That's why I didn't do it. But I can do it, right?